Good. Good morning, everyone, and welcome to Making Use of the Building Control System for Improved Operations and Energy Efficiency. This is our first day of the training, and so today we're going to start off with a couple of just kind of general items, our program overview, and then we'll start getting into the meat of it. Next slide, Ted. And one after. We will be meeting every week between now and, May 23rd. It will be our last session. All the sessions will be recorded, as Kim already told us. So they will be available in the lobby as soon as we get them uploaded after that day's session. Attendance is important, though, whenever possible, especially because we have interactive parts to this, discussions, and some lab work that we'll be doing as well. So this is our general or our agenda for the day, kind of go through our background and purpose. We're going to do introductions, all of us on the leading side and you on the participating side. We're going to have a group discussion about what your biggest concerns with your facility are. And then we're going to get into some presentations on energy efficiency, electrical theory, and then get into the control side on sensors, inputs and outputs, all those kind of details. And last up, we will talk about the virtual building that we are going to get to use as our playground and lab space for this workshop. I'm sorry, training. Wrong turn. Ted? So this is where we get to introduce ourselves as the leadership team. Peter?
Good morning, everyone. I'm Peter Crabtree, the principal investigator for the NSF ATE Building Efficiency for a Sustainable Tomorrow Resource Center. And welcome. We're so glad that you're here, and we hope that you have a great experience with this professional development activity over the next 5 weeks. Larry?
We'll let Larry introduce himself here after a little bit. Jingjing?
Sure. Hi, everybody. My name is Jingjing Liu. I'm a technology researcher at Lawrence Berkeley National Lab. So I'm the principal investigator of the overall project that we are contracted with the Department of Energy that enables this trading. So I'll say a few more words, but for now, just welcome.
Ted?
Yeah, and I'm Ted Walensky. I'm an instructor at Milwaukee Area Technical College and also co-PI for the BESS Center. And I'll be one of the presenters today talking about various aspects of controls and the basics.
And I'm Robert Nirenberg. I'm the founder and principal of EduControls, former instructor at a community college teaching HVAC and building controls, and former co-PI of the BESS Center as well.
And I'll try this one more time. Yes, my wish is that Zoom would automatically unmute when I need to speak. But anyway, save that for another Christmas. Welcome, everyone. I feel like I sort of know you since I've seen your names and I've been in communication with some of you. I'm Larry Chang. I'm a registered architect and director of BESS Center, and I've been part of this since fall of 2012. So, thank you, Robert.
Thank you, everyone. Ted? All right, now we're going to get into our background and purpose, and I'm going to turn this over to Peter and Jingjing. Peter, you're up.
Okay, thank you, Robert. So a little bit about the BESS Center very quickly. We're funded by National Science Foundation, as we said. We And this particular program, this BAS training program, comes with support from the Department of Energy and the Healthy Schools Initiative. And it's a partnership between the BEST Center and Lawrence Berkeley National Lab. BEST has for many years provided professional development for business, building science and engineering education, sustainable building operations, and building automation systems, where we've had a lot of our focus over the past 13 years. We're a collaborative network of over 70 colleges across the country, as well as controls manufacturers, industry associations, building services companies, public agencies, and industry experts. We've been partnering with Lawrence Berkeley Lab for more than 20 years, and we do that in order to disseminate advanced research in building science technologies and their applications in the field. One final note, we have developed a national certification for high-performance building operations professionals, and you can find out more about that at hpbop.org. Some of you may be interested in signing up and taking the exam for that certification. It is ISO ANSI aligned. The certification is informed by 20 years of NSF-sponsored research into best practices in building operations, and it's been endorsed by the National Institute of Building Sciences. Next slide, Ted. And a few notes about our approach to professional development here. It's informed by years of industry and educational experience. So it's kind of a dual thing. It reflects what we've learned working in industry and collaborating with industry, and at the same time honing tools that we believe can more effectively impart learning. And as part of that, we emphasize experiential learning. We want to make sure that you get your hands on the tools and use them, because that's when learning really takes place. And we emphasize an industry-informed application of tools. So you'll be using the BAS tools in the lab portion of this training as if you are in the field using those same tools. We will be getting feedback from you along the way. It's a collaborative learning environment, and we'll try to make sure everybody keeps up. We do embrace an ethos of continuous quality improvement, so we'll be looking for feedback along the way as well. And finally, we want to emphasize a systems approach to improving building operations. And that's really at the heart and perhaps the most difficult thing to impart, that what happens in one part of the building affects what happens in other parts of the building. And an override or a change to one set point can have implications elsewhere in the building. So that system level analysis is something we'll be touching on as we go along. Next slide, Ted. Oh, by the way, that building you see there in this slide, can you go back for a second, Ted?
Yeah, sorry about that.
That is the Flex Lab at Lawrence Berkeley Lab. You are going to be connecting to a server running BASView 3 connected through the system there. And we have Lawrence Berkeley Lab, along with other national labs, has developed a simulation model called BobTest. And you'll all be connecting right into a server at Flex Lab as you use these online tools. So we're very excited about this process that we're going to engage with to do that work. Okay, next slide, Ted, sorry. And I'm not going to spend too much time on this slide. I think this is information that's well known. Each building has its own unique story. And the whole design and construction phase is fraught with lots of issues, issues that are well recognized by the architectural community and the engineering community. Often the buildings are never commissioned. There's a kind of disjointed control design process. Many of us are subject to low-cost bidding. There can be value engineering. All of these factors come into play. After the building is turned over, we have to make it work. And most of the building's life cycle is in that long O&M phase. Capital improvement projects tend to be layered on, subject to budget controls, and of particular relevance to us, the control systems themselves are often upgraded in a piecemeal fashion, and they will coexist with pneumatic systems and older systems and earlier generations of one product or another. So you may have multiple generations of a control system working, as well as pneumatic controls. Very seldom does anyone upgrade the entire control system all at once. So it's a complex set of issues to deal with. Finally, the organizational culture is very, very important. Do you have a proactive or reactive maintenance program? How much do you rely on tribal knowledge, the traditional way of doing things? How much does the organization provide professional development for the frontline workforce in building operations? And how much support is given by management for the operations staff? These are all critically important. Next slide. Jing, could you speak to this slide for us?
Yeah, I certainly can, but I want to kind of also back up a little bit. So Peter, is that would be your last slide or?
No, not yet.
Okay, then I'll just briefly say that so the training that we deliver is focused on the buildings, the automation system to help you familiarize with its capabilities and some of the basics to get around it, using it for improving the efficiency of your building and certainly towards saving energy cost. And but the larger picture behind it is that our electrical utility systems today are undergoing a lot of big transitions, really new challenges that we haven't seen because of the deeper penetration of renewables, and also just technology innovation, certainly related to controls and automation in general. So we recognize as a DOE national lab, we do so much innovation on the technology side, and we recognize there's a very big gap, a growing gap, between those technologies that are being pushed to the market. And the training that we have in a sort of old-fashioned for the workforce. So we are very proactively trying to address this gap. So that's just as some context of that. Back to you, Peter.
Okay. Next slide, Ted.
Oops, one too many there.
and I think this is my last slide, and you can comment as well, Jing. Why is this training important? Uh, we believe that the use of building controls is at the heart of efforts to improve building O&M. Building controls are often poorly understood and underutilized by O&M staff. Training will focus on using basic BAS functions and tools to maximize benefit. There's so many things that you can do in a building, and if you get into a retro commissioning project with a professional engineer, there's so much that can be done. However, we kind of believe that if you can use the basic BAS functions better and more effectively at the ground level, you can accomplish so much. And that's why we focus on these basic BAS functions that we'll be focusing on over the next sessions. Because right there, there's so much potential for improvement in operation, energy efficiency, energy conservation, occupant comfort, creating a better learning environment in your school, just by using the basic tools to maximum effect. And with this, the control system can be used with greater potential. And as managers, you can set higher expectations and goals, and the operators can execute those improvements. And Jing, do you want to add to this?
I will just say a few words in addition. Ted, do I have ability to share a couple slides? It's not super.
I believe you do. I will unshare me and then you can take over.
Okay, thank you. Okay, here we go. Yeah, thanks for the introduction, Peter. I'll just kind of build upon it a little bit more. Like I mentioned earlier, this training pilot is made possible through funding from Department of Energy, specifically the Efficient and Healthy School programs, which you see kind of in the branding of this slide. Some of our participants here your school district may be already part of this program, but if not, certainly good for your information because that program is longstanding and has been providing a lot of really useful resources in terms of trainings and good information and cohort learning type of resources to our schools. And we recognize that the schools is an audience, a sort of a sector that deserves a lot of attention. You know, before we proposed this project to the DOE, we heard stories like school districts that have control problems that they don't have the in-house expertise to address, and they have to spend money hiring control contractors from out of state come over to fix almost every control problems for them. And as you can imagine, it's so hard to afford that kind of spending for our public schools these days. Not to say all the delay of fixing problems, right? There's a big need in terms of helping our schools to build up in-house capabilities to address at least some of the common issues that we encounter. This training is definitely trying to address that problem head on. And this is the second year of our training pilot. And as you can see in the picture, the Flex Lab facility, which is a really unique test bed here on our Lawrence Berkeley National Labs campus. And we last year used this facility as a sandbox for our trainees to poke around and learn about how to use building automation system interface. And we created some falls with the best centers expertise so that you are basically learning and practicing in a risk-free environment. Um, and that's quite essential, right? When you are learning these, how to address these issues, it's not the best place to start with the actual equipment at your schools. So that's what we provide, and we have received a lot of interest, a full sign up, and very, very, very positive feedback from all the participants and saying we need more of those kinds of trainings. So that enabled us to do this pilot in the second year, but we are doing it with a little bit different flavor. Like Peter said, this year we're really trying to increase the classroom size by using a virtual platform called Bobtest. It's been developed with investments from the American Society of Refrigeration, Air Conditioning, Heating Engineers Association, and also the Department of Energy is certainly developed not just by Albinel, but lots of collaborators. So it's a very realistic control platform. So it comes very close to how real systems work. So we are for the very first time using that capability, and Robert is really invested a lot of his time and expertise on making that available to all of you. So thank you to Robert, and also because this is the very first time we're using it. So we would also really appreciate your patience if there's a little, bumps that comes along the way, just knowing this is the first time. And, like Peter already mentioned, the control trainings are definitely not abundant. That's really, it's a very well recognized gap in this industry, both in terms of among vocational schools, even in four-year colleges. It's very hard to find really good control programs that also allows hands-on practices. But yet, problems are in every corner of facilities within schools and beyond. So it's these problems are not only affecting the services in the buildings, keeping our students and occupants comfortable and healthy, but they also have these implications, like Peter said, in the efficiency, which translates to how much the schools have to pay for the utility bills. And that is in competition with the very limited resources that we have in the schools for other things that they could have been spending money on, like, all these projects that are backlogged. You are very familiar with that. So, so here in this class, we are really bringing the combined expertise of knowing the controlled automation systems, how to make things work and how to make things work efficiently to you so that hopefully this becomes really useful in your daily work. So I'll also just say we're also trying to deploy similar training, maybe a little bit longer version of this to community colleges that's in Best Centers network and providing these critical vocational trainings to people all around the country. So your feedback in this training will be so valuable to us for us to learn what goes well, what you find most useful, and what's your wish for improvement or other things we can cover in future trainings. And if you would like to share similar training with your colleagues or just your fellow facility professionals in general, we would so welcome your feedback because this year's training is basically enabled by the feedback that we received from last year's participants. I'm just showing you an example of that. So with that, that's all I have. Again, welcome all of you. We hope you really take away a lot from this training. Thank you.
Okay. Back to our next slide, and this is where we flip the table and everybody in the audience, all our attendees, you guys and you people get to come out and talk about who you are, introduce yourselves by stating your name, organization, city, state, what position do you have? What are your goals for this workshop? You know, what do you want to get out of it? And what control systems do you have at your facility? So with that, I'm going to toss it over. Robert and I will try to kind of pass the baton to people as we go through, and I guess we'll start out with Gene Kelly.
Morning. Can you guys hear me?
Yes.
Great. My name is Gene Kelly. I'm with Rockingham County Schools in Rockingham County, North Carolina, just above the Greensboro area and the Piedmont. My position is the energy specialist for the school system. We're in a rural county. We have 4 high schools, 4 middle schools, about 12 elementary schools spread across 572 square miles of space. And I am the primary driver and person that is on the building automation system. We are under the proprietary system of Johnson Controls, which is Metasys. And I'm hoping to learn just kind of, it's been about 11 years this summer that I'm in this position. We started an energy program 11 years ago. And so a part of our savings, our driving part of our savings has been through manipulating time of day schedules and, you know, hanging with the changing of the seasons that we have in North Carolina as far as settings are concerned. And I'm just hoping to gain more better understanding of the building automation systems through providing efficient, improving indoor air quality, and helping our folks and our students. Students, bottom line is learning. So if we can improve the environment, we believe that they can, you know, make those outcomes. Thank you.
Yeah, just a point on that, Gene. Having a good quality environment, there's been lots of studies in the late 90s that point to improved productivity in commercial and build and industrial spaces by that, and also in schools, improved grade scores, much fewer sicknesses, illnesses, and absent days. So you're on target with that.
Great.
All right, Jessica Moore, you're next.
Good morning. I'm from Kodiak, Alaska. I'm the information management specialist for the Kodiak School District, which basically means that I manage the CMMS system, our computerized maintenance management software. But our building systems technician left unexpectedly last summer, so I ended up sort of tasked with running our building automations as well. So I've been learning more or less by the seat of my pants. We use our most modern system we have is Delta Controls, which is 2 of our facilities. We also have a Distech control system, and we have several Network 8000s. So it's a kind of a hodgepodge of everything, and it's been a super fun learning curve. So I think right now I'm kind of at the point where our newest building, which is about 10-year-old high school, has a number of communications issues, and I can't tell if it's the sensors that have gone bad or if we've lost something in the network. So I'm hoping to learn more about how to troubleshoot the sensor side so I can, determine where to go from here. We're a really super rural place. We've got 14 schools all spread out over Kodiak Island, very maritime climate, so it's super mild here. We only had 2 snow days last winter, but in the summer it rarely gets above 70 degrees. So we have no AC in any of our units, just heating and outside air controls. I hope that's helpful.
Jessica, just as a note on that, one of our past PIs on the Best Center, his comment about things you see on your system where errors are happening, the most common item is loose connections. So you might want to think about that as you go on. All right, Adam, you're next.
Hey everybody, I'm Adam Schultz. I'm on the East Shore of Maryland. I'm the energy manager for Wicomico County Public Schools. I took on this role last year coming from the infrastructure department where I was a system admin. And one of my tasks in that role was rebuilding all the servers related to energy management, virtualizing them, updating them, making sure they adhere to best practices. So it piqued my interest in this field. I was never aware of how much energy the public school system actually consumes. It is our second biggest expense next to compensation. I guess my goals for this series are to learn best practices, ways to improve our energy usage reduction, and any other funding opportunities or training programs. As far as control systems, we use reliable controls. We use modern controls. We have some legacy Barber Coleman systems that I'm trying to get rid of. We also use an events management program called Massivo, which ties into all of our BACnet to do our unoccupied scheduling when we have events and make sure the lights and HVAC kicks on if needed. And that actually ties in through API in a program called Events to HVAC, which talks to all the controllers at all the sites.
Quite the complex system you've got going on.
Yeah, I didn't even go into the lighting controls, but I'm not a fan of them. We have also 2 proprietary lighting systems. One is used to be called Starfield. It is now Starflight, and it is using a proprietary form of DALI. It is not BACnet compatible. Just so many issues. Had issues from the moment it was put in. We also have a Crestron lighting control system, which never worked from the get-go. So it's, and I actually was the technician at the site that had the Crestron system. So I was told not to touch it and let facilities manage it. But unfortunately, when you solve problems at a site, you become the guy. Mm-hmm. And it got thrown in my lap. And once I bite, I'm not letting go. Once my name's on it.
Yeah. I'm going to be installing a PoE system in a room this summer. So we're going to see how that goes. Power
over Ethernet. What's being powered?
Well, they're 30-watt fixtures, so we'll run
light fixtures.
Yeah, light fixtures, 30 watts a piece,
and they're entirely PoE.
Yes.
Interesting.
So I'm going to take a 120 plug it in the wall, and run with it. We'll see how it goes.
Well, if you have PoE, you shouldn't need a utility power.
Yeah,
It's a standalone system, Adam, that he's installing, so he has to power his PoE switch.
It's all PoE.
You're powering the switch. I see what you're saying. I got you.
Yeah, exactly. And we just plug it right into the wall. Anyway, I should get on. Shouldn't dominate.
Yeah. Thank you for the time. Yep.
Thank you, Adam. Damien, you're next.
Hi, my name's Damien Hill. I'm with Laken Peninsula School District in Southwest Alaska. I work in the maintenance department. We have a maintenance department of 3 that cover 10 schools off the road system. So our commuter is a Cherokee 6 Saratoga airplane. I do everything from unclogging toilets to writing CIP applications on the state level and everything in between. Our system is a Siemens DeSigo, and it's very robust, and it saved a lot of time traveling to the school districts, or sorry, to the school sites. We're able to troubleshoot remotely. I've also installed some IoT sensors in specific places that are prone to freeze up. So, you know, if the crawl space is starting to get cold, we can say, hey, open up the hatch for a while and let's warm it up when it's, you know, 40 below. So I like the term, I just learned it, the tribal knowledge term about this is just the way we've always done things. And I'd like to get to more of a predictive nature of our operations. And it's really helped out the remote sensors. What I'd like to learn is I'm starting to use EUIs a little more and trying to interpret that to become more efficient. And 3D modeling of the schools to start doing things such as digital twinning, so we can walk through buildings with people while we're off site and they're on site. I don't think we're covering that, but that's kind of the next step that I'm looking at. And
We actually will be talking a little bit about EUI, or energy usage intensity, in our 5th week when we start doing some energy analysis.
yeah,
So that you can look forward to or not, depending on your proclivity for math.
I like all of that. And just you know, energy efficiency is just paramount in Southwest Alaska in general. Some of our sites we're paying $10 a gallon for heating fuel. We're purchasing some right now for $6.50 a gallon. So the tanker truck gets off the landing craft, drives to the school, drives to the teacher housing, offloads 10,000 gallons of fuel for, you know, the next couple of years, drives back down to landing craft and gets out of there. So, you know, there's no pipeline. Kilowatt hour, 92 cents a kilowatt hour, $1.50 a kilowatt hour. So anywhere where we can find efficiencies is very important. And then integrating renewables into that's starting to come also.
Yeah, you know, just as a support for you, the people in this room have a lot of knowledge, so ask questions. I myself have 45 years of experience dealing with schools and energy efficiency. So ask away.
Yeah, could any of you come help me flush out some heat exchangers, please?
Well, I don't actually do a physical labor on it. No.
Yeah, nobody really does that. I'm sorry. We have a labor shortage, all right.
Jason, you're next.
Hello, Jason Bang here. Sorry, I'm just joining here, but I'm with Ann Arbor Public Schools in Ann Arbor, Michigan. I'm our Director of Capital Programs. And so my goals for this workshop series are to better understand how our, what was just being discussed, how we can better increase the overall efficiency of our portfolio through better control. But also we have a particular building that is on my radar, an all-electric high school that integrates a geothermal system and is our largest energy consumer in the district. And it is very important that we get the building kind of operating as designed. And one of the ways in which we can do that is to fully utilize and take advantage of the control system which exists there. And I think it's always been an issue for us. So hoping that I can take away some better understanding of how we should be using our control systems and how we might be able to bring some solutions to this particular high school. And so I think what I'd want to do is just become more familiar with optimizing controls, and we have two systems in the district, JCI Medisys and Niagara Tritium. I hope that makes sense.
All right. I think we'll pass on next person. Melissa.
Uh-oh. Can you guys hear me okay? I'm having camera issues, but are you able to hear me?
We're able to hear you just fine. Thank you.
Fantastic. Here, let me see if I can get on camera. Anyway, it may not work, but anyway, we'll carry on. My name is Melissa Kreiser. I'm the energy manager for Klein Independent School District. And we are a school district that serves about 54,000 students. We're just on the north side of Houston. We have 5 high schools, 10 intermediates, 33 elementaries, and about 10 ancillary buildings. We have about 9.6 million square feet of conditioned space. As far as control-wise, we have reliable controls, web control through automated logic, Climatech, and we also have some Delta campuses, so 4 different control systems. As far as what I'd like to learn, and I have my team in here with us as well, we're watching you guys on the large screen. I think just learning anything that we can learn to improve our program. Right now, we're running about $1 per square foot for our ECI. So, but we can still stand to improve. So looking forward to this little lesson here, this program.
Thank you, Melissa.
Welcome to you
Okay.
and your team.
Yeah.
Your camera didn't work, by the way.
Thank you.
So you can do it again.
Jeremy. How about you? You can unmute yourself and.
Good morning. My name is Jeremy Colson. I'm a maintenance supervisor at the Anchorage School District in Anchorage, Alaska. We monitor about 92 schools. There's 63 elementary schools, 12 middle schools, and around 16 high schools. I've been a plumber with the school district for about 18 years. I've got promoted to a leadership position as a maintenance supervisor here. And I've been in this position for about 3 years. We currently are using Siemens Desigo, Siemens Apogee, and we have one building system that is under lawn controls. One of my goals is trying to figure out some more tips and hints on how to do energy management, and anything I can take back to my team here at the Anchorage School District.
Thank you, Jeremy. Kaylee.
Hello, I'm Kaylee Miranda. I work with Jeremy in the maintenance department. I am the major maintenance project manager for the Anchorage School District. So while Jeremy and his side, they perform the maintenance, I perform anything that falls between what is outside of the scope of our maintenance team all the way kind of in the middle up to our capital projects, which 2 of my other coworkers are on this and they'll talk about that. But as Jeremy stated, we are a pretty big school district. We have over 43,000 students. It's 2,000 square miles. And there's also, of course, our facility buildings. You know, we have, well, he mentioned we have 92 schools. We have almost 100 buildings overall. So it's a large number. And we do not currently have an energy manager. So the scope of energy projects falls diversified amongst our capital group, the maintenance group, and myself, just to try to see what we can do. And that's kind of what I'm here for. I'm here to learn what I want to focus on because I did not come from the automation side. I'm here to learn more about the system in general and how I can help facilitate my team. Thank you.
Thanks, Kaylee. Dan Ortiz. Guess I'm probably catching people here. Dan, if you're not unmuted, make sure you're unmuted.
Ted, why don't we come back to Dan later?
Yeah. Okay. I think there was a Jonathan. Lost my participant screen here, but Jonathan, you're next.
Hey, good morning, everyone. Jonathan Earls. I'm with Orange County Public Schools in Orlando, Florida. We are a public school district serving kind of the Orlando metro area. We have 230 K-12 schools and then, some support facilities. I am Senior Facilities Director for the district. I'm responsible for the teams to take care of existing schools. So, maintenance, custodial, smaller capital projects. Goals for the workshop series is just to kind of further my understanding of building automation systems. Our power bill is north of $60 million a year. And being a public school district in Florida, there's considerable financial constraints that we're operating under. So I think one of the big strategic initiatives for us is going to be, how can we better utilize our facilities and our capital investment to lower our operational cost and lower our utility bills. So hoping to kind of get a better understanding of really where we should be focusing our efforts. There's a long line of people that are lined up to sell us all kinds of solutions, but and I just I like learning, so I'm looking forward to kind of getting into the details a little bit. So what control systems we use? So we have Schneider Electric, Trane, and Allerton, our three main control systems.
Great. Carlos.
Hi, everyone. So my name is Carlos Gabriel Pazos, and I work at Orange County Public Schools in Orlando, Florida. We take care of more than 200 and I think 230 buildings, I guess, right now, between elementary, middle, and high schools, and also administrative buildings. I work as an energy advisor. I'm relatively new in this position and with the OCPS as well. So I'm trying to learn everything that I can. I've been in the position for 5 months, so the learning curve is still going up. So I hope that I can learn all that I can and try to find new opportunities to make our schools more efficient and also to save money for the school, for the district. And related to the control systems, we use Trane, Allerton, MC Squared, and KMC. So we have at least 4 control systems that we use. And yeah, that's it.
Thank you, Carlos. Nina.
Hi, I'm Nina Molina with the Anchored School District, again, alongside Jeremy and Kaylee and one more. I am the planning assistant, and I'm still relatively new to this entire thing. So I'm trying to get as much training and learn as much as I can.
Great. Thank you. Dan, are you able to unmute yet? Are you able to get to that point, or? You are, go ahead and unmute.
So we can see that you're unmuted, Dan, on Zoom's end, but we can't hear you if you're talking.
All right, well, we'll move on to the next person. We'll come back to you, Dan. Yash. Santosh.
Hello.
Morning.
Just a moment. Yeah. Hi, my name is Yash. I work at Lawrence Berkeley National Labs. I am in Jingjing's team. I also recently joined. It's been 2 months since I joined, and I'm also trying to learn the basics of building controls, more specifically for energy side. And I'm here to learn the basics and also learn everyone else's experiences and what challenges they are facing and what are their interests for this seminar. Thank you.
Yash. Tyler.
Hello, this is Tyler. I'm with Des Moines Public Schools in Iowa, and I'm the energy and environmental specialist here. We're the biggest school district in Iowa. We've got 69 facilities, about 32,000 students or so. Kind of excited to learn more about the building automation system that we have. It's Johnson Controls with Metasys throughout all of our facilities, and kind of looking to determine learn what points we need to really focus on. There's a ton of data that comes out of the system, and kind of figuring out which ones are the most important to both increase indoor air quality and energy efficiency, which is a big important piece here for us at Des Moines Schools. Yeah, like I said, we're all JCI, so.
Okay, Aaron. Aaron Hope.
Good morning, everyone. My name is Aaron Hope. I am with Durham Public Schools in Durham, North Carolina. This is a probably urban, suburban, and slightly rural school district of about 59 schools, 32,000 students, about 6 million square feet. And yeah, I think my position here, I'm the energy engineer, energy manager, program manager, and goals for the workshop. I am pretty familiar with the various building automation systems, but just want to meet everybody and maybe see if there's something I'm missing, or other opportunities to learn, but also maybe to contribute in some areas, in terms of like strategies for energy management and conservation, utilizing building automation systems. Our primary building automation system is the Tritium Niagara 4, but there are some legacy systems that are probably built on top of just through like BACnet drivers and things, including some Metasys stuff. Johnson Controls, some Barber Coleman hardware that's still kind of out there, the pneumatics and stuff. So yeah, kind of a hodgepodge, as others have said, and things that were built on top of each other. Some loose wiring here and there, and but yeah, probably nothing out of the ordinary. But yeah, just a lot to manage. But yeah, that's it. Happy to be here.
Yeah. All right, let's go on to Larry Morris.
Yes, I'm Larry Morris. I'm the Planning and Design Supervisor for the Anchorage School District. You've already heard from other people. We have about 7.5 million square feet of space. And I want to learn out of this, better utilize building systems to reduce energy costs and improve indoor air quality, as well as help reduce ongoing maintenance costs. for the systems. But I'm also old enough that I can remember and able to program an old Andover 256. So it's been around for a while. So that's it.
Thank you, Larry. Okay, Charles Massey. We'll come back to you, Charles. Adam Sini.
How you doing? My name is Adam Sini. I work for Radnor School District in Radnor, Pennsylvania, right outside of Philadelphia. I'm actually an HVAC service / maintenance technician. There's 3 of us in my department. We take care of all 7 buildings in our district. Unfortunately, we use Schneider Electric TAC iNet off of Windows 7. So we're very far behind. So we're actually starting to make the switch to Distech's Niagara. It's going to take a while, but we're starting at the high school and slowly working our way through the district. I hope to just, I deal a lot more with the units. I deal with the front end. I can do some of the stuff on the back end, but we're doing a lot with service and maintenance and installation. But just trying to take anything I can out of this. We'll eventually, once we switch over to the Distech platform, we'll eventually get training through them, which hopefully will allow us to do some of the back end things where we can program and things like that. But right now we're kind of just drowning. I shouldn't even say we're trying to stay afloat, but yeah, it's pretty tough with what we have. I've only been here 4 years and the other 2 guys have been here less than 2 years each. So we're all kind of not familiar with this system. And we're just working our way through it. And our controls company, Sassmore out of Jersey, they help us as much as they can, but yeah, not really too much help there because a lot of it's antiquated and outdated. So
sounds familiar. All right, pass it off to Justin.
Yeah, good morning, everybody. I appreciate being here. I am one of 2 building automation managers for Baltimore City Public Schools. We have about 150 buildings, and for the last 6 years have been building a team that didn't exist. We were essentially given the directive to build a building automation team. So we having that many buildings, you can imagine we have everything from legacy to modern and probably every system that's out there. We've really spent a lot of time working on how to integrate 150 buildings and all kinds of various systems. We've learned a lot about integration and what it doesn't mean. But essentially we've pared down to 4 primary vendors. That's going to be Johnson. So we're using Metasys, Izego, EcoStruxure, and we have some Niagara as well. And we use Train's Synchrony. So we keep joking around that we're growing into problems that we've never had before because we're still a relatively new department. And so part of that is that journey with our energy management team. And now that we're starting to get a grasp on, schedule management and setbacks, it's very eye-opening how much we can actually save implementing those strategies. So yeah, just getting an idea of industry trends and anything that can help us on this journey as we continue to move in this next chapter.
Where are you, Justin, again? I'm sorry, I missed that.
Baltimore City.
Baltimore, okay.
Okay. Lindsay Elliott.
Hi, let me see, hold on. I was having some struggles up until now, so I'm still kind of getting oriented. I was here, but I realized I was in the lobby. So anyway, my name is Lindsay Elliott. I am from the Parkway School District in the metro region of St. Louis, Missouri. I am the sustainability and energy coordinator. My background is in biology, but then also in education. I started my position about 3 years ago and just kind of had to jump all feet into the energy portion and anything HVAC. So I've just tried to learn as much as I can, as fast as I can. And I've had some really great folks who are helping me out, but I still feel like there are gaps in my knowledge. So I'm hoping this can help me make sure that what I have learned is correct and that I'm not missing anything. And whatever I am missing, that, you know, I'm learning more about it, similar to a lot of you. So our school district is large for our area. It covers a lot of, I guess, geographic space, but our student body is about 20,000, and we have about 31 buildings that are on Automated Logic's web control. So I'm fortunate in that they're all on the same system of controls, but there are a few that under legacy controls, and then other schools that are not, like areas, large portions that are not controlled yet. We're trying to get those online. See if there's anything else that I wanted to share. Just how to impact efficiency, because I do manage our utility budget, and that's probably about 4 million for gas and electric that we spend. So anytime I could take that down is wonderful, but also I'm trying really hard to coordinate with our maintenance department and our HVAC leads, because in the past, communications and the, I guess, I don't know, just relationship with them wasn't always the best. So I really want to find ways that are going to benefit them as much as possible. So if anyone has any advice in that area, I'd appreciate it. But I try to work with them to find things that are going to help efficiency and the money, and also just the planet on my end, but is going to help them out at the same time. So the comfort of the buildings, they get less complaints, you know, or maybe equipment that continues to fail, if I can bring commissioners in and help both of us at the same time. And that's a big part of what I'm trying to do. So again, I'm excited to see all of you here and to learn some things. So thank you.
Thank you, Lindsay. Lily, you want to introduce yourself?
Hi everyone, my name is Lily Yu. I am with the Lawrence Berkeley National Lab. So I'm based in Berkeley, California. I am a technology researcher. Well, I don't operate the buildings here. It's shameful that I don't know the control system that we're using. And that's also one of the reasons why I'm here. I want to gain some knowledge and also some hands-on experience for the building control system and also the HVAC system. So nice to meet you.
Thank you, Lily. Dan Ortiz, are you able to chime on in, introduce yourself? How about Charles? Charles Morris.
Can everybody hear me?
Yes, we can.
Yes, my name is Charles Massey. Hello, everyone. I work for Orange County Public Schools, and we've had here in Orlando, we've had a couple of people talk about our school district. It's really big. You know, we have over 200 schools. We have ancillary sites. And I think we have somewhere in the neighborhood of 300,000 students. So there's a lot going on in this district. My primary background is electric utility. I work with Florida Power and Progress Energy about 22 years. And then I came over here to the school district. I've been here for about 13 years. I'm always in and out of our building automation systems. We have 4, Train, Allerton, MC Squared, and some KMC. There's 5 energy advisors in the district. And then we also have 2 energy control techs. And then we have building automation techs in all of our maintenance areas. So we we try to stay on top of our BAS systems, but there's just so much going on. We're building new schools, we're renovating new schools, we're changing out legacy systems to newer systems. So I feel like I learn something new every day. And so that's really why I'm here for the training. I mean, it's, this field is just so vast, and the amount of knowledge you need is also vast. So I hope to gain some more insight, with the BAS systems. One of the things that we do is we schedule after-hour events in the schools, and you can only imagine with 200 of them, there's always events that we're scheduling. 2019 or 2020, we used to do everything manually, and we decided, this is crazy. So we now integrate we've integrated quite a few of our schools with Facilitron. So they're a third party, and they come in and the schools enter their reservations into the Facilitron system, which talks to our building automation and schedules everything automatically. So we've done quite a few schools. We still have a long way to go, but that's definitely helped with the manual labor of scheduling after our event. And so maybe we can talk about that a little bit as we go through the training.
Okay. Well, good. So Dan, if you're able to unmute at some point, just feel free to jump in. We're going to move on to our next slide. And
We've got a couple of folks who still haven't introduced themselves yet, Ted.
who's that? Oh, I see somebody.
We've had a few people join and some that we've just, I think, missed by my list. Adam
Yeah, I
Sini?
have 26 listed. I guess number 27 would be Liwi.
Hi, everyone. Sorry, I was on the lobby view. My name is Louis Giussessi with Montgomery County Public Schools in Montgomery County, Maryland. I'm an indoor air quality specialist. And I've only had the opportunity to dabble with the BAS systems that we use, and we use a number of them. We have a dedicated BAS department, but I'm trying to gain a little bit more understanding and knowledge, so I'm a little bit more self-sufficient and I don't have to go back and forth to them to provide further instruction. So yeah, my takeaway, I just want to learn as much as I can so I could be self-sufficient.
Great. Is there anybody else who has not spoke up and can unmute themselves? Okay. I think with that, we're going to go ahead and go on to our next slide. And my screen is not cooperating at the moment, but Robert, you want to just start on that, talking about it, and I'll get the screen up there.
Yeah, absolutely. So you've done a great job with introducing yourselves. Thank you. Welcome, everyone. Actually, I suppose Ted and I should probably introduce ourselves a little bit as well. So we gave you our names, who we're with. From an industry standpoint, we've been around for a little bit. My background is predominantly controls and building management, though I have dealt with that from the contractor side, as well as the building owner and maintenance side, and teaching, obviously, I already mentioned. So Ted is a professional engineer, mechanical engineer, so he's been around the industry for quite a while and dealt with a lot on the energy management side. But
yeah, and a lot of that has been focused on schools over the past 40 some years.
But do not take us wrong. We do not know everything, and we will not tell you that we do. So
By no stretch of imagination.
and we'll talk a little bit more about that here in a minute. But right now we want to do a a little bit of a group discussion sharing facilities concerns. And you've already shared a number of them, but if there are a couple of these that I think really are worth looking at a little bit closer, because there's a lot of commonality between your problems, because you have a lot of very similar buildings in their usage, which it was one great thing about this group. But I noticed a lot of you have one big problem that you share that I'd like to talk about and see how you're dealing with right now. And that's a variety of systems. So I know some of you mentioned having systems as old as pneumatics. We heard some about Andover AC256 and Micronet, the old Network 8000 by Barbara Coleman. That's actually the system that I cut my teeth on in the controls industry, believe it or not. So, but systems as modern as current generation Siemens and Johnson systems at the same time, and Schneider, Tritium, Distech. So, how are you dealing with that particular problem? And then we'll get into the rest of the discussion.
Yeah, and you can just unmute yourself and start talking about it, say who you are and tell us what concern or case you have. Or you can put, there's a place you can sort of raise your hand here in Zoom, and you can use that. Anybody have something they want to talk about?
Hey,
Oh,
it's Adam Schultz here. I put change in culture. Like, how do you deal with, I know you mentioned that people are trapped in their ways and stuff like that. Like, I'm encountering a lot of resistance, and for example, we charge sticker charge for teachers to have a mini fridge. I'm trying to get that increased because it's been the same rate since 2007, in which it didn't even cover the cost of electricity. So I guess one of my questions is one of the things that you brought up. How do you get people to adjust to trends that they're not used to?
Boy, that's a hard one. You got any thoughts, Robert?
Yeah, cultural change is almost always very challenging. And if you start talking to folks on the behavioral side, one of the things that they will mention as a useful tool is explaining the change in a way that benefits that person or that group of people. So with folks like us who are dealing with maintaining the buildings, things like energy savings are kind of a no-brainer, or disbursement of costs when people have something like a dedicated.
I was told to always say cost avoidance, never say savings, because then people think we're getting money to spend. That's one of the things, and one of the early advice I was given in this role is, if there's money to be spent, the school system will grab it quick. So always say cost avoidance. One of the things I was thinking too is kind of frame what you're saying as, the money that we're not spending on energy is money that we could be spending on supporting students and compensation. I've also I've been pulling a lot of our Energy Star portfolio manager information into Power BI to make it a little more digestible for admin. And I've learned that admin love to see numbers and charts.
Yes.
So I think one of the main things that I need to do is get the information to all the stakeholders at the very least.
Communication in any of these sort of efforts is absolutely key. If you can show them the data and show them how they will benefit, or the group that they represent or care most about will benefit, then it becomes a lot easier of a task, because they can see the goal is benefiting this group, and now they're on board to help you move the ball from point A to point B.
Right, and frame it as a common goal, and not, I'm just trying to be a stickler and save money on the bills.
Absolutely right. You may benefit in the process by saving money on the bills. I'm sorry, avoiding cost on the bills.
Cost avoidance, right? Yeah.
But yeah. So
We can learn
that's
too.
That's a great one. You guys aren't pulling punches with asking the questions, which is great.
Thank you.
Thank you, Adam. So we've got a couple here in the chat. Aaron, who was, if I remember right, was down in Florida or thereabouts, or maybe Georgia. Apologies. High humidity in the southeast. So yeah, humidity is a very significant problem in many of our areas. And a lot of times, especially when we're trying to improve our indoor air quality by bringing in more outside air, we have that balance of energy efficiency and indoor air quality, but we also have to deal with things like high humidity, which, Ted, you got any suggestions on that?
For high humidity?
Yeah.
Well, you just need to keep on your controls to make sure that humidity control is working. The other thing that comes into mind, a very common occurrence with high humidity inside buildings, is having a building that was designed but currently is not operating at design. So in other words, outside air conditions may be putting all those external loads on you and providing that humidity. However, inside the building, where it was designed for, say, 30 people in a room, now it only has 2 people in a room, or other loads inside the building. So you may not have the loads in the building, but somebody has not set up the control system to adjust the design to conditions to what it's currently operating. Primarily, there is thinking about the airflow as a whole. When you have too high of airflow, you can't bring the temperature down to meet the load in the space far enough to draw out the humidity in the air. And so you want to make sure that in cases where you're running into humidity issues, that you don't have a lot of VAV boxes, for instance, that are providing a lot more air to spaces that don't need it. So you want to cut back down on that. So the idea is you want to run less air through that cooling coil so you can drop the temperature down low enough to get below the dew point to bring the moisture out. And maybe that's a little too technical for us here, but it's a matter of too high of airflow, not enough load, can't pull humidity out. Unless you're directly sensing for humidity and that's driving your systems, then that's a better way to do it.
And a couple of points that Ted hit on there that I really want to emphasize with this is your sensors. Make sure your sensors are operating properly, that they're within calibration. Airflow sensors in your VAVs do need to be calibrated periodically. You need to check up on your temperature and humidity sensors to make sure that they are within calibration. Use some sort of reasonable calibrating instrument to check them in place. Don't take them off somewhere. Make sure they're in the situation you would be using them to test. And you may find that you've got to replace some sensors as part of that. But then there are also strategies that can be employed, to Ted's comment on the design intent or sequence of operation of buildings. There may be some stuff there that is inactive because it wasn't originally set up properly. To Peter's point earlier about buildings not necessarily working 100% as they come out of construction. And it's our job to live with them and figure out how to make them work, right? But there are some potential solutions there, but humidity is a huge concern in many areas.
And I think your point about the sensors is accurate too, because what I have seen over the years is that humidity is a very difficult thing to measure. And so your accuracy of a humidity sensor not only is not that great, you might be within plus or minus 5% on a good day, but they also are difficult to measure, so they often go out of calibration. I had an example of that where we were commissioning a new building, control contractor said they're ready for us to test it. We go in and all the humidity sensors were out of whack. He says, I just calibrated all those last week. That's probably a little extreme, but still it points to the fact that for humidity, those sensors need to be checked for calibration on a pretty regular basis. I would say at least once a year, especially in areas where you're having problems.
Yep. Same with your CO2 sensors. Those can get out of
Yeah.
calibration as well,
Yeah.
and do need to be checked. Most of the manuals that I have seen recommend checking them yearly as well. Because if you have some demand control ventilation systems within your buildings, and those CO2 sensors that are driving those are out of whack, you can end up drawing in more air than you need.
And if you don't, I mean, most people don't have time to check all those things on a regular basis. And so if you just hit up your problem areas where you think you might have an issue, that'll probably get quite a few of your problems.
Yeah, hit up the problem areas first, and then set everything else up on a rotating schedule as much as you can. Go check the sensors in one building per week or something like that on your bigger school districts. So next one that I see, and I'm just pulling these out of the chat right now. So if you've got another one, put it in the chat or raise your hand and we'll get you unmuted. But too much dependency on outside contractors. Everybody's got that problem, right? You've got stuff that you can't fix either because you don't have the internal knowledge in your team, or that you don't have time to fix because you're dealing with other things. And so you have to call in an outside contractor. So it's really hard to fix that second problem of time. There are only so many hours in the day, right? But the first, increasing the knowledge, that's why you're here today. And here for the next couple of weeks is to increase the knowledge in your team. We're by far not going to be able to give you every tool that you can have as far as the building automation system goes, but we'll do our best to get you the basics so that you can understand more and be able to get more out of your system, to also be able to ask those contractors when you bring them in the pertinent questions so that you can reduce their time and learn from them in the process, hopefully. So,
and the other aspect of that, Robert, is I noticed in when people introduce themselves, quite a few people from very large districts, but very small number of people that are actually in controls working in hundreds of buildings. So you don't have the time or staff, which you alluded to. So what that tends to do, and it's difficult to get administration to want to free up more money to have more control techs or HVAC techs who can do controls. You want to be able to get to the point where you know more about pulling in good contractors and working with them, get the language in whatever contracts you have with them to make sure they're doing the job they need to do and not more or not less. So there's, it's a balancing game, because they're paying, the school district's going to be paid for one way or the other, and they tend to like to go to the outside contractors more than using inside help. I personally feel that they need to be more towards the inside help than outside contractors. But you, even in that situation, you can't always have all your expertise in-house, even in large school districts. So that's always going to be an issue. And it's always going to be a matter of definition. Our definition of too much reliance on outside contractors is going to be different than administration's definition of that. So something to consider.
absolutely true. And there are a couple of items that kind of go into that here that are in later questions or comments about general budgeting, and hopefully we'll give you some tools to get some cost avoidance with your energy costs in the process of this training. And hopefully that'll help you justify reallocating some of those funds towards helping with training or additional staffing to get some of that internal experience in the case, or take off some of that pressure from the budget side of external contractors. Adam does point out, however, that sometimes the systems are locked down and you have to call a specific vendor or contractor for support. And yes, that's absolutely true. It is getting to some extent less so. In the old days of controls, it really was very vendor specific once we got into digital controls. So that's a long running trend, and there is a lot of work that can be done if you know how to ask to get your systems unlocked, especially for those of you who are relying on Niagara systems. Those are inherently intended to be contractor agnostic, but there's requests and things that you have to do sometimes to do that. Charles, you've got your hand up.
Yes. Hopefully we'll have a chance to talk about alarms, but all of our DAS vendors, all of our systems have alarms, but as you know, with a complex chiller system, you can get alarms that will just overwhelm you. And so we're always trying to figure out, like, what are the critical alarms that we need to pay attention to, that maybe we get emails for, instead of, you know, having your inbox flooded with alarms that really that are not critical, that don't need, you know, like immediate attention. So maybe you guys can talk about that a little bit.
Absolutely, Charles. You've got it right on the head with that. Alarms have to be useful. If they are not actively useful, and there are some requirements, at least in my mind, for an alarm to be useful. But yeah, it can be a challenge, especially with a new building or a new to you building. When engineers design a building, they have a list of alarms that they think you need, but the reality may be significantly different. And we will be talking about alarms as a very specific topic in week 3. So we will get into that and address it. So I don't want to go super in depth, but yeah, managing alarms alone, it can be a challenge, but it shouldn't be. It should be something that helps you, not hinders. Other items of discussion? Big concerns? Small concerns?
Well, you know, one of the things that came up that I thought of as people were talking, and of course, we all kind of speak to our own background and what we're familiar with, right? And that's what's going to come out here. When you look at energy, I noticed one thing in the chats there that Jonathan talks about. We're looking at energy, trying to save energy, and I heard one person speak to it, and I wasn't quite sure if they had a energy tracking system, but energy tracking systems are a good way to follow what's happening in your buildings and help you to troubleshoot them. I've done some work in some school districts where just by watching energy, just by paying attention to your building's maintenance, you see a drop in consumption by 6 to 10%. So it's a pretty good payback when you're doing that type of thing. Of course, like with all things, the longer you do it, the more kind of fades in the background for you. You got to figure out ways to make it new again once you start getting down the road on it. How many people here are using some form of energy tracking system? Maybe if you can just kind of put in the chat, or actually just speak up to it and tell us what kind you got. I know my company has, I have a company, Walensky Associates. We've been doing energy tracking for the better part of 30 years now. And ours was developed on spreadsheets. And a software program put out by Abraxas years ago called Metrics. And right now, those spreadsheets, last revision I did on was quite a while ago, so they're kind of fading the background because I'm shutting the company down, so I don't use that anymore. But Metrics is one software package. MATC, who I work for, also they use a company called WeagleWise to track their energy. And you need to be aware of different aspects of that. Anybody have any other experiences with different types of software they're using?
We're using, and I just came from a training conference called Catalyst, Energy Cap, in Atlanta over the last, it was Tuesday through Thursday. And so we've been using that when we initiated the energy program, build the database 2 years back before we started the program. And then we load in all of our utility expenditures, natural gas bills, electric bills, water from the vendors and various others. And it deals with cost avoidance. I mean, that's the CAP stands for Cost Avoidance Program. So Energy Cap, and it is
okay. Yeah, I recognize that one.
Yep. So I highly recommend it. It's a subscription, and it's well worth it. Not only can you track your cost avoidance and savings, but you can load in interval data from your utility vendor. Your finance office can use the other end of that, the accounting end of that program. It's pretty comprehensive. Run all kind of reports, use all kinds of shared graphics for leadership to log into and kind of see, once explained, how they can understand the information. Then they can click in and see that information from week to week, month to month, see how they're doing as far as energy savings. So that's what we use.
Energy Cap's been around in one version or another for a long time. I would venture to say on the order of past 25 years.
At least.
So it's got a good base. So yeah. Anybody else using software? Thank you, Gene.
We also use Energy Cap at Orange County Public Schools.
Oh, okay.
Looks like Brightly is also on our list here. Pushing some data towards Portfolio Manager, which I know Ted will be talking about on in week 5 as well.
Good free software.
Mm-hmm. Classic,
So it sounds like
manually entering into a spreadsheet. I played that game for years.
And I still do that. The one thing with any software you use for that is, what I have found over the years is, the more detailed you can break out the energy that you put into it, the better you are able to hone in and troubleshoot problems. And in particular, I know a lot of software packages, they just bring in the total kilowatt hours. Well, you really need to break that out. And Gene was talking about this from a standpoint of interval data, but you really need to break it out in terms of on peak and off peak, so you can differentiate times of data it's being generated, or your demand's being generated, and that really helps you with figuring out, okay, is this an override issue? Is this a particular building's change of use issue? It can really help you to fine tune that. So that's a critical component.
And to Adam's point, as does sub-metering where you can do so. They're using Shark meters, but there are a huge quantity of especially electrical meters, smart electric meters, for live monitoring, interval data, but it allows you to divide up your loads so that you actually know and can kind of isolate where you may have a problem. I've used them in the past to the point where I was able to find short cycling compressors because of it, which was really kind of a surprising benefit. Not something we planned on when we installed them, but really helped.
I see that they're hoping to get OpenBlue up and running from Johnson Controls. And I'd be curious to learn more about that over time, if they are able to get anything in place for you, Tyler, as we proceed through these different sessions.
Yeah, same
So-
here. We've been hearing about it for a number of years, and hopefully they're able to implement something.
Yeah. Yeah, it would be interesting. I think the main thing is you got to get started on it. You know, some people mentioned CMMS software they're using, but when you get into it, something's better than nothing, and it'll get you on your way. So, the more detailed ones are great for people who are really analytical and want to dig in, but getting something going is better than nothing. Anything else popping up there?
Some other varieties, BACnet enabled meters through Schneider. And I know we're talking a lot about electrical meters. Do keep in mind that there are gas meters and water meters that we can be adding to, and those are items that are worth watching as well in most cases.
Yeah.
And you
No,
may
something-
even have existing meters within your building. A lot of modern electrical specs will require that some smart metering be included. So it may be there and just not being actively used, and it's just a matter of getting it set up.
Yeah. I'm kind of curious, Adam Schultz, you mentioned IT. Do you have an IT background?
Oh, I have 2 degrees in IT. I've worked in IT for over 20 years. So I definitely am bringing a lot of my IT skills into this, and I'm finding a lot of parallels.
Well, it's kind of like Robert. So we won't hold that against you, but
Oh no, we're universally hated. Feel free.
Yeah. Don't
No.
worry, Ted isn't on better standing. He's a mechanical engineer, so
Oh, I wish I got into EE instead of IT, but I was born with this gift.
yeah, well, IT for this type of work is really beneficial. Really
It
beneficial.
definitely is. Being able to process this data in Microsoft tools and stuff like that has saved me, and it helped me identify so many errors.
Yeah. Yeah.
so one item
Anybody else have some major concerns? Sorry, Robert, I kind of interrupted you there.
No, you're all right. I was just going to ask, I know we've had some folks mention it previously that they're using third-party software on top of their control system. I'd imagine some data analytics type stuff, whether it's in-house from your preferred controls manufacturer, or you're not preferred, but you've got to use them anyway, controls manufacturer, or complete third-party systems as well. Anybody want to address your usage of them, why you started using them, how it's going, problems that you're having because of that software? No takers? I know someone mentioned specifically alarm management through an ALC tool a little bit ago. Yeah, here we go, Lindsay. I'm using Analytic.
Hi, yeah, so for some background, we've been using a monitoring-based commissioning platform that was initially grant funded, I believe about 10 years ago, but long before I started. So I've just learned about the history through, other folks here. And I feel like its usefulness had been kind of patchy, and then I got here and didn't know a whole lot, and I have keep trying to make it useful, and I haven't yet, and I had a lot of great plans to have it be more useful. So it's monitoring based commissioning in the sense that it's, continuously commissioning our buildings by plugging into our web control with automated logic and taking those same data points that, our BAS is doing, but creating that third-party platform of charts and graphs to make it easier to gather those alarms and figure out where the issues are. So a little bit redundant, but the goal was to make everything easier. Had big plans, but had significant budget cuts for a variety of reasons. So that's actually getting wiped from my budget as of next year for the first time in over 10 years. So I was kind of looking at, okay, well, Automated Logic has their own version from what I can tell of that. And our, vendor like sales folks are saying it's similar, and that's that analytics program. It seems to be doing similar. So I'm interested in that, but I've not used it. And that's what I'm curious is if the cost will be better, but still be able to get some of that usefulness and actually be the same, program and company that we're already using. So I don't know if anyone's used any of that, I'd appreciate it, but we haven't gotten there quite yet.
Anybody have some experience with that? And the one thing about that, Lindsay, is that you using a software package like that, it helps to pull the data and look at it from the perspective of trying to troubleshoot. Whereas if you do it just off your control system, it's generally not set up to do that. So it's good to have that third-party platform to do that.
Yeah, and honestly,
Anybody else
our guys who are, working with the system in maintenance, honestly, are overwhelmed by the alarms. Not working with efficiency, just, and so it's hard for me to watch that happen with them too. So we did have some help in, condensing all of them down, but I think it's still just overwhelming when your staff has been depleted. Like you all said, we have those same problems everyone else was talking about too. So it'd be nice to help everyone, not just myself.
Yeah, and that's a very common problem when you get into things like that, because somebody hasn't done it before. There's going to be a lot of problems, not just having to determine what really should be alarmed, what doesn't have to be an alarm, but also addressing all alarms that come into play. We came across that. We hired a part-time person from the program that I teach to address the control systems at MATC. When he got on, he spent the first third of a year or so just going through the alarms and thinning them out. And that's all he did. That's all he did. But he got that under control. He's not there anymore, so I imagine it's probably piling back up because nobody's there, just like you mentioned with cuts. Nobody's there to take care of it. Actually, ours isn't cuts. It's trying to find somebody available that we can hire that can take care of those things. So we're trying to address those issues too, but yeah. Anybody else?
Charles has one. This was more of a question, but yeah, so asking if we are going to talk about trending or data logging as part of this training. And yes, we absolutely will. We will start talking about it next week, and we will use it and work more with it in each of the following weeks. Because most of our control systems have the ability to do internal data logging, which means they're recording the data at a much higher rate than is typically capable for us. The college that I was the energy management guy for, we had an old Andover system when I first took over that position, and it doesn't have the greatest of data logging capability, but it beats an engineer walking through the boiler room and taking manual readings twice a day. So, but, getting that data out of the systems, that's, going to depend on what kind of system you have. Some systems have good ways of viewing the data internally, some do not. So getting it to a way that is useful for you, it is a critical tool and ability. But yeah, we will be going into that and how to use that data to your advantage.
Well, maybe, Robert, if there's no more things people have as concerns, the facilities that they want to talk about right now, we can go to our break. What do you think? Or did you find something else?
Adam added in a more thumbs up on alarms and related to startup times versus polling times. And yeah, you've got to tune in your alarms. Again, a lot of times out of the box when your building comes out of construction, it will have alarm timing that is set by your engineer or the controls tech's best practices. But that doesn't mean that it's right for your building. Every building's a little bit different. So, kind of tuning those in right off the bat, and anytime you do any significant updates can be important. That way your alarms are useful and not just a nuisance. Adam also suggests backing or making sure IT is backing up your control system servers periodically. And yeah, that we are reliant on IT in most of our situations to help us ensure the integrity of our data. The trend log data is one thing, but just the functionality of your system is, we all know how critical it is, and we know how critical our conversations with IT can be. So working with them instead of against them is not always easy, but it is definitely important. All right. So
Okay.
yeah, Ted, I think we are on to our next slide, which is
The break.
a break.
Let's take a 10-minute break and come back at about I can't see any of my clocks here. Got them all covered up with stuff. Come back at about 5 after.
Yep. 5 after
And
the
we'll
hour, please.
5 after the hour, and we'll start back up then.
See everybody in 10 minutes.
Hey, Robert.
Yeah, I see your message, Larry.
Okay. Thank you.
As
Thank you, Kim.
soon as I get it up here. There we go.
Fantastic. Yeah, welcome back, everybody. So, as I already stated, Ted and I know a lot, but we don't know hardly everything. And we fully admit that. And actually, both of us really enjoy not knowing everything because it gives us the opportunity to learn. So, the way we like to run trainings like this is we learn as a team. That includes Ted and I and everybody else in this group. So everybody has specific knowledge that, you've got something that you know that nobody else in this room knows. I guarantee it. So when you have contributions, please make them. It may be easier to make them in the chat. It may be easier to raise your hand to talk about a topic a little bit. We are going to do our best to stay focused so that we can keep to schedule in the process, though. So try and be respectful of everybody's time. As we all know, time is that one resource that we can never get enough of, right? So also ask questions. Ask lots of questions. If you don't understand something that we said or there's a topic that's related, ask. Please. It will help Ted and I direct the course of our experience here a little bit. And, there is no such thing as a stupid question. I firmly believe that. As long as you truly want to know that answer, then it's a good question to ask. So please do. Either put the question in the chat or again, raise your hand, which you do by coming down here and clicking on that little react button down at the bottom of your Zoom screen, and then you'll raise your hand. It'll pop up in the corner of your icon, whether you have your camera up or not, and we'll be able to react to it. And we'll do our best to remember to lower your hand after we've answered your question. So as long as you've got that question active or comment active, please keep that hand up. Ted and I also will team up on this very much. One of us will typically be a lead presenter. The other may jump in with specific comments, but the person who's not the lead presenter will also be handling a lot of the chat. So maybe answering questions directly or posing those questions to the active presenter. So today you'll kind of get a feel for how we do this. And we'll just kind of keep going with it as we go. But we'll adapt to what you want to learn, what you need to learn. We've got specific goals ourselves, but we'll get absolutely as much in as we can. Ted?
Yeah. So good. I'm assuming you see the ask questions screen right now, and there's nothing else on it.
We're seeing learning as a team and ask questions.
Ah, okay. That's interesting. I apparently have the wrong screen up for you. I'm going to just change that out so that I can get the right one. There, how's that one?
Still seeing the same.
That's interesting. Oh, huh. Well, I'll start talking through things, and when I get a break, I'll change it out. So we are going to go into energy efficiency and electricity. Just kind of take about a half hour and step through that right now. So energy efficiency, and we're going to cover a couple different areas, basics of energy efficiency, and then we'll talk through electrical, the 4 basic things that we typically measure on electricity, and relative to controls, and cover a little bit about AC versus DC. We got about half hour. We're going to run through this information. So energy efficiency, the definition of it is using less energy to achieve the same level of service or output, minimizing waste and maximizing productivity. So what that basically says is efficiency is equal to the amount of useful work we get out of something versus the amount of energy that we pay for to put into it. And I think there's kind of different definitions on that end, but I think of it in terms of what energy we pay for. So now let's get into a little bit about energy savings. So when we look at energy savings, a lot of people like to grab the low-hanging fruit because it's easy to do. And you typically get quite a bit of bang for the buck out of that. And we're going to talk through some examples of that and where you look for that in particular with controls, which we've actually hit a lot of that already today, but we're going to just go back through and make sure we cover all of it. You see on this slide that, let me see here. I wish it was set up right. But anyway, on the slide, you see a picture of a campus. This actually happens to be the campus where I work. Nice graphics. This is right off the BAS system, showing the different parts of the buildings and grounds. But then below that's a graph. And it's just showing some data turning on and turning back off, and that schedule is operating. A lot of us have graphics in our systems that allow us to see this, and it can be very helpful to spotting some of the low-hanging fruit. So control energy efficiency basics, and we look at what are some of the best opportunities within a building control system to gain efficiencies. And I'm just going to have everybody kind of open up their mics and let me know what you think of as opportunities that you see in your facilities.
And you can also put those in the chat if you'd like as well.
Robert, I'm going to let you grab that as people provide them, because I want to get the screen set up right.
You got it?
All right.
Tyler says schedules. Absolutely.
Schedules is a big, and they're simple. It's easy to address them.
Occupied, unoccupied modes, overnight setbacks. Yep.
Yep.
All commonly referred to as parts of schedules. We've got set points. Yep. Having the right set points in the right spots. Good outside air control, for sure.
That gets into our economizers.
It
That's
does.
really important.
Demand response, that's an important one for those in areas with variable rates. Plant enable set points, when we're turning on and off our plant equipment to be appropriate. Staggering equipment startup times, yes. Specifically trying to do it outside of high demand windows, getting things started up while you're still on the cheaper power, yes.
Oh, $96,000 per year phantom load. That's a pretty high phantom load. Yeah. And those are things we typically run across, easy areas to grab energy efficiency. So I think we kind of hit them, schedules. Well, actually, we didn't really go into overrides and resets. So those are the three big ones. And looking at your schedules, addressing your overrides and hitting your resets. So now I'll talk a little bit more about scheduling. So one of the big ones, which was hit here, I think in chat, is looking at schedules and looking for things that are 24/7. As a general rule, there are very few, if any, systems that need to be on 24/7. And by on, I mean occupied mode. So you want to get those set into an unoccupied mode as often as possible. Trying to take the time to be focused on narrowing down those occupied time frames is really important. Those tend to kind of broaden out. I mean, human nature is we'll go in and let's say that there's an after school activity. Well, we'll just expand that schedule for that day rather than using a temporary schedule. Well, that expanded schedule now becomes the rule forever unless you go back and change it again. And that's an area where energy efficiency can be had just by going back and making sure you put it back to the usual schedule that the building operates, which kind of gets us into a little bit of the warm-up area on scheduling. I don't know, Robert, if you want to talk a little bit about this, but there's different type of warm-ups that we can implement on our controls, and they fall in the categories of warm-up or optimal start-stop. And Robert, you want to just give a quick overview of those?
Yeah, absolutely. So the intention between a morning warm-up or morning cool down or optimized start-stop, all talking about very similar concepts, is bringing the building temperature up at just the right time so that when we're hitting the active usage time of the building, that's when we are at our temperature. We're not trying to bring it up to temperature 2 hours ahead of time if we only need 30 minutes of time with that. And of course, it is season specific. Sometimes you won't need hardly any time because it's one of those comfortable shoulder seasons. Other times when it's, blazingly cold outside or hot outside, you're going to need more time to bring the building back into its operational standards. But, again, you've got to be careful with that and get the schedule set up and get that starting time set up properly.
One of the key things with that is when you're in occupied mode, you're scheduled on time, you're bringing in outside air. When you're unoccupied, you're not bringing in outside air. And that's a big energy consumer. So if you can utilize on your controls some type of warm-up scheme that will typically operate without outside air, saving you money. So it's a conservation effort. Other areas for, go ahead.
In an economizer mode where bringing in outside air actually is the way to save money on cooling a space. But that is usually not the case.
Other schedules for indoor and outdoor lighting can be very important. So scheduling is a really good way to save energy. And a lot of the things we talked about, Energy Cap software for tracking utility use, on the company that did that originally, they put big effort into having those districts that use their software hit the schedules and really tighten them up. And it's a really good way to save energy. Now we go into overrides. And with overrides, and I see this on our control system a lot, where actually they're doing better at it now, but you could go on a system any day and there's a bunch of overrides. And overrides can be a huge energy waster. I saw it the first summer I was in the buildings at Milwaukee Area Technical College. I knew right away that somebody had overrented a lot of the VAV boxes, because this gets back to our earlier discussion. You could really feel it was humid in the building. In the summer, there's very few classes in session. The building's basically empty. And yet we had high airflow. Our VFDs on our air handlers were 80, 90 to 100% open all the time. And that told me right away that systems were overridden, not operating correctly. And I could feel it in the building. And I knew it just by walking in that it was humid in there. And it was like that every day. So you encounter that on a regular basis, and you know to start looking back at the unit to find out if there's a lot of airflow. And indeed there were a lot of overrides implemented on VAV boxes to 100% open. So they can be a huge waste. So overrides, they affect your schedules, your output set points. In short, anything you can write a value to. And they're very useful because we use them to work on something, to impact a problem that occurred. But if we forget we put them into place, that's where you really get into the area of wasting energy. So they're not inherently bad. The third area is resets. And so on the left, you see a graph. That graph is basically a reset. You're going from one condition to another condition based upon some type of input. So what's the purpose? Adapt a set point to operating conditions. And it really has an impact on energy. A prime example of that would be discharge air on an air handling unit, or the hot water temperature on a hot water heating system. Those are two good examples where resets are used. Historically, we reset hot water temperatures based on outside air temperatures, and now we have even better ways of doing that to maximize the efficiency of the boiler system. So it has a huge impact on efficiency. So are there other areas? Robert, what are some other areas you see some resets?
One of the bigger ones more recently has been supply pressure resets from air handlers for variable volume systems. So that, again, we're not moving more air or wasting energy by creating pressure in our ducts that we don't really need. So it's really just a way to help the system automatically tune itself to be as efficient and effective as possible.
Which really gets us to a point, you know, that supply pressure reset has an impact on total airflow, which goes back to the fan and the fan motor. And anytime you're operating a piece of equipment at a reduced load back at that motor, you're not just saving that reduced load percentage, you're actually following a cube law for saving energy, so that if you have an air handler that typically operates at 100%, and then you go and you're operating it on average 50% of the time, or 50% all the time, then you're going to save 0.5 cubed, which, what's the math on that, Robert? That takes us to what? 12% or something like that? 12, 13% of the horsepower required. So you're really reducing your energy requirements. And that's a huge, huge benefit. So anytime you have the ability to do VFDs or use VFDs and really cut back, you're going to have a lot of savings. All right, so that's the resets, which now that gets us into our next slide. Unless there's anything else in that, Robert, you want to cover?
No, we will be covering all three of these topics more throughout the training. We actually have basically a week dedicated to each of these to help the understanding. There's more information that comes along with each of them, of course, but these are major topics for us.
And that's where you'll cover the question about what's static versus dynamic, right?
Absolutely.
Are we taught, this is Damien. Are we gonna be talking more about VFDs?
Robert, I don't think we have a lot of VFDs in here, do we?
No, we don't specifically have anything about VFDs. They are an end tool. Is there a specific question you would like answered about VFDs, Damien?
Yes, what are the pitfalls of installing a VFD on an existing system?
We can talk about that a little bit where we have some time for it, but
Okay.
mostly that's beyond the scope of what we should be talking about here. But
That's fine.
we'll manage it anyway.
Okay, thank you.
I'll tell you one that stands out right away is you just can't put a VFD on an existing motor and expect it to operate correctly. You have to make sure you have the correct motor for operating a VFD. That's one pitfall. So.
Adam, you got your hand up. Go for it.
Yeah, so we have VFDs going into our newer sites, and one of the tasks that I was presented with by our planning and instruction team for this summer is seeing if we can push the set points a little more, being that we now can control the airflow a little better and not have to worry about some of the mold issues that come from turning down your set points in the summertime and stuff like that, because you're not pulling the moisture out, not having the airflow. So that was one of my thoughts when you mentioned VFDs, is that you definitely can tune them, but you have to find a balance.
Yes, you're absolutely right. And that type of conversation we will be having in, I think it's week 4.
Okay, yeah, so
into resets and set points.
The other case I saw him is Pepco put some in when I was the facilities director at the Ward Museum. And the rationale behind them there was they actually lessen the strain on the motors, because the blades and everything were so heavy that if you just shut it off entirely rather than ramping it down, you cause stress on bearings and all kinds of other things. So that's the other thing to consider about VFDs if you have large air handlers and stuff.
Yeah, and there's all these savings that accrue, not just energy wise, but from a maintenance and life aspect of equipment from using VFDs.
Oh, they definitely make sense. There are benefits. I haven't heard of the pitfalls apart from cost, but I mean, you're going to encounter that with any retrofit.
Yeah.
So for now, let's table the VFD conversation for just a little while. We will bring it back up at a later training though. There's definitely enough interest here that we should cover it. So.
Robert, are you seeing just my screen on electrical theory, that slide?
Yes, sir.
Okay, good. I just wanted to make sure that it was showing correctly. All right. So now we're getting electrical theory and covered 4 basic electrical measurements and AC versus DC. But first, let's just talk a little bit about what electricity is. I want to say a little bit. So electricity is the flow of electrical power or charge. So there's a basic part of this that's just what nature does. And it's one of our most uniform or most widely used forms of energy. When you think about it, electricity is everywhere. We're using it for everything these days, and we're trying to do a lot more with electrification of different systems so that we can get off using natural gas or fuel oil. So it's something that is all over and becoming more and more important, as if it wasn't important enough already. There's some information that describes electricity at this EIA government site, so you can go there if you want. So it's actually the flow of electrons, by the way. That's what electricity is. But I want to kind of put out a question. What do you think is the most used energy source for generating electricity? Anybody have an idea? You can just put it in the chat or raise your hand or just speak out.
Anybody?
Nuclear, renewables, natural gas or coal?
There we go. We're starting to get some answers.
Yeah, natural
Natural
gas
gas
or
or coal,
per se.
gas.
Some of this may be regionally specific, but I'm talking about the United States as a whole. So Adam's saying that nuclear is 40% where he is.
Yep.
That's a good high percentage.
Yep. Definitely some, the general consensus in the chat seems to be natural gas. Jessica, I'm jealous. 98% renewable.
Wow.
But there is some, a couple of folks saying coal as well.
Well, the Energy Information Agency, EIA, has published this data. It's not, there it is. As of 2023, which is the most recent year they have the data on, natural gas is 43%. So that's the one that's most common. Now, that's an increase from 2022. 2022, it was 39 point something. So natural gas, you can see, is starting to be more and more a percentage of what we're using to generate electricity. Renewables stayed pretty flat from year to year, and it's about 21%, just over 21%. I don't know why it's not showing the coal percentage and nuclear percentage, but they were less. I think coal was somewhere around 18 or 19, and nuclear was pretty close behind that. So you have this breakdown of what we're doing, and as we move forward, I was on some call yesterday where they were really talking that renewables are going to be increasing more and more, but we'll see what happens with what's happening nationally now as to whether that's going to hold true or not. So it's kind of interesting, you know. It's used to be coal for a long, long time, I think, until about 2017, and then natural gas took over coal. I've been watching it for a while for various reasons. So electricity, units of measurements, we primarily measure 4 different parts of electricity. One is voltage, and we use these digital multimeters here. You can see this. Digital multimeter is basically a controls tech's tool of choice. We use it all the time. So with that, you're measuring voltage. There's a range on a digital multimeter. You have AC and DC, which we'll talk about in just a little bit. And the same thing for amperage. We're going to be measuring either AC or DC amperage, and amps are the flow of electricity. Voltage is a potential. If you think of it as your garden hose, you turn on a spigot and it has a big rush when you first turn it on, high pressure, so it's equivalent to high voltage. And then as you start to open up your nozzle at the end and start spraying more and more water, you're getting more and more electrons out the end if you equate it to amperage, but your voltage or your pressure in the system starting to decrease a little bit. And we can think about that in ways that when we plug more things into a circuit, a wall socket, the voltage tends to drop, and you can see that when you're measuring it. Ohms is resistance, and you can see an example of resistance if you have a narrowing down of a wire. You don't get as many electrons going through, and that decreases the amount of amperage that you have available to you, and that also will tend to heat up that wire. And we can measure resistance. We measure in terms of ohms, and a subset of that, we look at ohms. We want to find out if our circuits are actually connected. In other words, continuity. And there's typically a on a digital multimeter a setting for continuity, and it'll let you know if you have a continuous circuit or not, which is another great troubleshooting tool. A lot about what we talked about this morning is energy conservation. And when we think of energy conservation, we're trying to reduce our energy usage, which starts with our power, which is wattage. We want to reduce the wattage. So we have to be able to measure that in watts. It's a matter of volts times amps times the power factor, which we'll discuss a little bit more later on about that. Now, what is AC versus DC? Well, DC is direct current. AC is alternating current. Anybody tell me whether this device is generating alternating or direct current? I know we haven't got into discussion about what these things are, but see if anybody can put in the chat what it is.
Damien is guessing both.
And the answer to that is no.
Jeremy
And-
guesses DC.
Yeah. So I'm going to not tell you, we'll come back to this. But I'm not going to tell you what it is, but we're going to go into definition of alternating and direct current. And then we'll come back and see if somebody can guess it. But this is an old steam engine. And it is, Damien mentioned it asked if it's an alternator. And there is an alternator at the end of this. It looks like a motor right at the end of the pulley. You can't really see my cursor well here, but let me see. So it'll be right here. See on the screen. That's pulley is connected to a alternator right back here. And that is what's providing the generation of the electricity. This is an old steam engine, by the way. We'll get into that in just a little bit so we can answer the question I asked. So here's alternating current, AC. So for alternating current, much like this diagram showing you, it goes from plus to minus, plus to minus, plus to minus. So you get a positive and negative voltage or current coming off of this, depending upon what part of the cycle you're in. And it just keeps running round and round, much like our, I'll go back to that a little bit. Anybody guess it yet? No, all right. So the times that it changes in a second, we call hertz. In the United States, we have 60 cycles a second, which we call 60 hertz. In Europe, it's 50 hertz. So if anybody travels, you know you have to carry with you, if you have a razor or anything else, something that can work off both 60 hertz and 50 hertz. But our equipment that we buy for our facilities, you have to specify one or the other, because it may not function if you buy a 50 hertz European style electrical piece of equipment and you plug it into our system here, because all of our utilities here in the United States provide 60 hertz. So changing 60 times a second, that's a lot. It's something where I'm told the human eye cannot perceive that, but I question that when I think about the old magnetic ballast and lighting fixtures. Wiring on AC is not polarity sensitive. You have a common and a power wire. And sources of alternating current are utilities or inverters, or in many cases, generators nowadays are putting out, we have them at our homes. There's, in the control industry, we generally think of it as 3 different types of voltages. Low voltage, which is 90-some% of what we get involved with. That's less than 60 volts. And you can touch the connections for something less than 60 volts and not worry about getting shocked. Whereas if it's line voltage, 120 volts or higher, you gotta worry about wearing some PPE, personal protection equipment, so you don't get injured. And especially true for high voltage, which we generally talk about as over 600 volts. DC or direct current is what most electronic devices today use. So if you think about it, what is Eric, I guess I just answered the question. It's true. Most of our equipment today that we operate in our homes is run off of, the electronic equipment is run off of DC. So if you think of anything that has a charger, anything that has a battery, that's DC. So our computers, our laptops, our phones, EV cars, LEDs, printers. We may plug a power source into a alternating current plug in our wall, but that power source changes it to DC so the device can actually use it. So DC, unlike alternating current, it's a constant voltage. Alternating is constantly going up and down, up and down, up and down. But direct current, it's just constant, flat line. It's polarity sensitive, so you have to pay attention to making sure that you connect the poles on a DC device up properly. You got to connect positive, positive, negative to negative. Otherwise, it's not going to work, and in fact, you may even damage your equipment. Sources are batteries, power supplies, solar. And you might think wind, but it kind of depends upon what part of the wind system you're tapping into, whether it's AC or DC. We already talked about different devices that use DC, so we'll go on to our next slide, which I guess that's you, Robert. Time for you to take over.
Before we move on, though, you've got to answer the question.
Oh, yeah, here, let me go back here. Does anybody have an answer? Do we want to take a stab at it?
DC or AC? You got a 50-50 chance. That was before we started talking about it.
If it's running an alternator, it's converting AC to DC. Unless that's the motor that you plug in to run it.
Yeah, it's actually generating AC, just like this device here. So we have a rotating device. We're running a steam engine here. It's taking opening and closing the valves on a piston, which is driving this pulley here, which is turning what effectively looks at a motor back in this area here. That motor, just like any motor, when you drive it in reverse, you could get electrical AC out of it. And that's what's happening here. Because it's constantly changing, it's flowing around and around, just like in that circle, you're getting that alternating current, plus, minus, plus, minus, plus, minus. So it's generating AC power. Any questions on that? We have to have, coming out of this device, something to change from AC to DC to get the DC out.
And in our modern car alternators, that device is integrated into them. But if you get an old enough car alternator, something out of the 70s era vehicle, for example, typically that device will be separate from the alternator itself. Damien.
I'm good. I don't want to get in the weeds. There's a bridge rectifier in there that converts it from AC to DC if it is an alternator, but I'm good.
Yeah.
Adam? Perfect. Anybody have any other questions related to AC and DC power, any of our electrical readings, anything like that before we move into our next section?
There's a lot one can go into on these topics. But in 30 minutes, it's kind of hard to cover.
Yeah. And we know that, to a number of you, this is probably really rudimentary stuff that you've known for a long time. but it's just establishing that baseline so we know we're all at the same, or at minimum level of understanding.
All right, Robert, I'm going to flip it over to you then.
Absolutely.
Get your slide up there. All right.
So next up, we're going to start talking about how controls work down at the base level. A lot of what we talk about, again, will be basics. So you may already know it, and that's totally awesome. If you don't know it, then bear with. So it's one of the things that we talk about with energy efficiency. We talk about a lot of the big stuff. We talk about schedules, we talk about overrides, but basic functionality of your system. If your system isn't working, if the sensors aren't working properly, if the outputs aren't controlling things properly, then you can make a lot of changes up on the software side that really will not have the impact that you're actually looking for or that you predict. So we'll get into that and talk about how these devices work. Ted? So first up, we talked about power a little bit already, obviously, but what kind of power do our controllers typically use? And here in the US, most of our controllers for HVAC or climate controls are going to operate on 24 volts AC, low voltage. So this is going to deal with things like our controllers, our actuator motors, thermostats, temperature sensors, pressure sensors, humidity sensors, most of our relays. Not all by any means. There are some devices that still use 24 volts DC, though, you know, those are more specific applications. Higher end sensors, some of our older humidity, CO2 or pressure sensors required 24 volts DC. And we do still occasionally run into some devices that use 120 volts or even higher sometimes for powering. There are certain controllers that still use 120 volts. Anybody, again, bringing back the old Andover system, they had a plant controller that ran on 120 volts, but they also had a fan coil unit controller that could take up to 277 volts out of its power. And that's a much more common occurrence if you start getting into the European and Asian markets, most especially European. But for the most part, we're going to talk about 24 AC. Ted?
Yeah, Robert, I've seen some damper positioners that operate off 24 volt DC.
Okay.
So another area.
I'm not used to seeing actuators or damper actuators running off of 24 DC, though a lot of them definitely can run that way.
Well, it's not the actuator itself. It's the device that provides a 010 or 420 milliamp signal.
Especially when you're talking about doing conversions from something like a pneumatic control system to a digital control system. That will be the case. And, you know, I'm sure some of you still have pneumatic actuators out there that are using exactly those kind of conversions. Oftentimes when we go to replace some of those larger pneumatic actuators, we will end up putting in electronic actuators or electrical actuators that need a higher voltage. They need 120 volts to be able to provide the torque necessary to replace some of those pneumatic actuators. That was one of the really amazing things about pneumatic actuators is if you needed more torque, you just put on a little bit bigger of an actuator and the torque gains were very significant. Less or more of a challenge with our more modern electronic actuators. But so for the most part, when we're dealing with controls, we're going to be dealing with transformers like you see in the bottom right-hand corner there. That's a universal transformer that's going to take in 120 volts, 277 volts, 208 or 480 volts. That's why we call it a universal. And it's going to give us 24 volts on the output. One of the key features on transformers that I personally will not install a low voltage transformer that doesn't have a built-in circuit breaker. I think that's a really simple thing. It's not a particular cost item, but it's a good protection to have. We do
And
have
it's really
some
critical in teaching. You need
Yeah.
to do that, otherwise you're replacing transformers all the time.
And we are starting to see more power over Ethernet, or PoE, in the industry as well. Ted talked about it earlier, about the upcoming lighting control project he has in one of his classrooms, where they'll be using PoE-powered fixtures, which is definitely one of the new and fun, exciting things now that we've got updated power standards for PoE. But traditionally, most of PoE is going to power things like the phone on your desk, or a lot of security cameras use PoE now. Didn't used to be the case. But PoE is DC voltage technically, or DC current. The voltage can vary. There are standards. Next slide. So once we get down to the control level, we get our controllers powered up. That's where the rubber starts to meet the road for us. We have inputs and outputs. Controllers are just a little computer. If they're kept in a bubble, they can neither do anything nor have any data to work off of. So we've got to give it data to work off of. We have to measure real world conditions. Anytime we are measuring things, hey Ted, you're blocking the slide.
I thought I had just the slide highlighted, but I guess not. All right.
Thank you, sir.
Sorry about that.
No, not at all. So anytime we are measuring real world conditions, then we're dealing with a sensor. We're dealing with an input. So we could be measuring temperature, humidity, carbon dioxide, carbon monoxide, pressure, any of those things. That's an input. If we are controlling things in the real world, then that's an output. So we're talking about things like actuators there. Collectively, we refer to this as I/O, input, output. And oftentimes, the part numbers for your various controllers will have some sort of reference to their I/O count, either individually as inputs and outputs separately, or combined. Our Bass Control 22 here in the image is a good example of it. It has a total of 22 inputs and outputs. Now, each type of input and output has, there are different types within that category. We have discrete inputs and outputs, or binary, or digital. These are things that turn on and off, nothing more, nothing less. They have an on state, they have an off state, nothing in between. Then we have our analog inputs and outputs. So these are things that can measure or create ranges. So when we're trying to measure temperature, since typically our temperature isn't going to be one thing or another, we want to use an analog input. Similar things are most of the time when we're reading humidity. So we actually want a specific number with our humidity, not just whether it's above or below a certain threshold. If we're monitoring the position of a damper or a valve, or creating that motion within the valve. Those are examples of where we are going to typically use analog inputs or outputs. And we can also do some clever things with digital points to create analog results. So most commonly with this, we're going to be dealing with things called pulses. So these are just a on or off signal for a specific amount of time, Or maybe we're just counting the number of times that we pulse. And we'll get into exactly how we do those and what applications here in just a second. And the other way that we do this is with a thing called a floating point. So a lot of times, especially with our more inexpensive actuators, so for things like fan coil valves, VAV dampers, things like that, a lot of times we'll try and get by with a less expensive actuator where we can. And we use something called floating control, where we literally have two signals. You can think of it like a positive and negative DC signal, though we, again, typically switch AC here. And we power it open or we power it closed. And for however long we decide to leave it on, that's how far we get. So again, ways that we can use digital to create an analog result. Questions on that so far? All right, next slide, Tim. All right, specific control signals. And I know there's a lot on this slide. Don't worry, we're going to cover it all and then some. So with our digital points, again, we just have on and off, but we can also equate those to open or closed, which is another common usage. When we have a valve or damper that just needs to be either fully closed or fully open, we're going to use digital a lot. When we get into our analog control signals, things get more complex. Depending on what we're trying to do, there may be some advantages or disadvantages to something. So now we're back to our electrical measurements that Ted talked about earlier. Voltage signals. So for us, these are always going to be a DC signal, and it's typically within the range between 0 and 10 volts. There are some specifics there. Obviously, we can do half that range, 0 to 5 volts. A lot of our older controllers, some of those of you running those old micro zones or some of the old Andover controllers, I know those specifically had maximums of a 5 volt output or input signal. Or we can do a full range of 0 to 10 volts. These work really reasonably well. We also have a lot of more modern devices, especially our valves and damper actuators that are running on a 1 to 5 or 2 to 10 volt signal. This gives us a really big advantage. But what is that advantage? Why would we want to use a 2 volt minimum signal instead of a 0 volt minimum signal?
And whether it's 0, 2, 1 or some other number, but something greater than 0.
Right, something greater than 0. Why would we do that? What advantage does that give us?
Just go ahead and either raise your hand or put something in the chat.
Keep up our pressure or
pressure
voltage?
or voltage?
Yeah, a little bit, but why is that an advantage? Wouldn't 0 be better? Then we're not using any energy?
And the second we start giving it voltage, it changes.
No signal at 0. You're absolutely right, Damien. At 0 volts, how does our system know, or our device know, whether it's a valid signal or somebody just cut a wire? So if we use absolute 0, we have no way to tell. But if 2 volts is the bottom of our effective range, our system knows that if it's getting anything below that 2 volts, it can raise its hand and say, hey, I've got a problem. This signal is not valid. So it can then go into oftentimes a default mode so that it is in a safe state. Our friends up in Alaska in particular are going to know a lot about that. Not that anybody here in the Midwest wouldn't as well. Because, you know, at night when things get cold, we don't want them to freeze, so we want them to be in a safe state. I'm sure down in the southern portions of the country we're the same, just on the other side of the spectrum. Okay. And it can also be a germination point for an alarm so that something can be addressed. Because we don't typically want our systems running in that default state for very long. But these signals, a lot of times we will use them for actuators, a lot of our sensors, and variable frequency drive control. There's that topic again. We can also use current-based signals. So,
Robert, before you go on to that, isn't there like another reason for using 1 or 2 volts as your trigger point, and that being getting some, for lack of a better phrase, stray voltage or imposed voltage on a system from some outside that then would start, if it was 0 volts, would start to trigger an actuator or something to start to move when you don't want it to?
absolutely. So what Ted's referring to here is a occurrence called induced voltage. So it's basically noise on our wires. Typically, we don't have a lot of things that are that sensitive in at least climate controls. But if we start getting into really high accuracy sensors that may be used more in a production environment or in something like a hospital or pharmaceutical manufacturer, then that is a more significant issue. But yeah, keeping above that low threshold really helps us avoid that as well. Though typically, again, we'll run into those issues more with our communications wire than with our signaling cables here. And it's why we tend like to use shielded cabling in those situations as well. And for reference, that 1 volt or 2 volts is referred to as a floating zero, if you want to impress your friends at dinner conversation tonight. Damien, looked like you might have something to add.
No, I just need to stop talking. Just ghost voltage, right? Is that what you're talking about?
Ghost voltage is another term for it,
Gotcha.
yes. And no, you absolutely should ask exactly those kind of questions, man. That's what we need, because one thing we haven't talked about yet, but is definitely an issue within our industry, is lingo. So there are official terms and unofficial terms to say different things, but a lot of them are very regional, and they may be very dependent on what portion of the industry or what education you came to in that, to where we are now, as to what you call something. Could be induced voltage or electrical noise or ghost voltage. Those are all valid ways to describe it, and just depends on the region.
Spurious voltage.
Spurious voltage, yep, that's another one. Yep.
I've run into that a lot around, I guess it's LED lighting, and trying to get proper readings on your voltmeter. And there's I found the low Z mode to find that ghost voltage is like 60 volts, or if something's just weird. Yeah, interesting stuff.
Yeah, it is. It really is. And that kind of gets into power quality issues, which is a much more electrically focused conversation. But that type of terminology also applies to lots of different things. In this training, we will tend to call it a building automation system, BAS, as our preferred abbreviation. But at your home facility, you may call it a building management system or an energy management system or a control system. We're all talking about the same thing, just using a little bit different set of words to do it. And as long as we understand each other, life is good, right? But when we start confusing what we're talking about, you know, to me, BMS, building management system, could also be battery management system. So we got to be careful. But absolutely always ask any question like that. If I use a term or Ted uses a term you're not familiar with, please ask. Clarity is important. Communication is key.
Definitely.
Other questions on our voltage-based control signals? Okay. If you think of them, just put them in the chat or raise your hand. Moving on to our current-based control signals. For us, this is really exclusively 4 to 20 milliamps. Current measurements are much harder to do with our multimeters, especially in the low current settings. The meters that we use to measure these in a clamp-on style are very expensive, you know, to the tune of $2,000 or $3,000 usually for the low-end models, and going up from there. So what's the big advantage we would have for a current-based signal? Why would we bother to use it? And I got two really good reasons for this one.
I haven't seen anything come in the chat yet.
It's okay, Ted. I'm patient. I used to teach high schoolers. Anybody? Wild guess. I know the person who remembers how to program Andover AC 256 ought to know at least one of these. No takers? Okay. Well, one of the major reasons is because we kind of grew out of the production controls industry. It would be a variable amperage signal. Yes, Damien, that is what it is. But that's not the reason we use it. But we grew out of the industrial side. I would disagree with that contractor, Jessica. And in industrial settings, they use 4 to 20 almost exclusively for their analog control signals. And the reason they do that is because it does not care about how much distance we have on our wire. It doesn't care about how much resistance is applied. If you take something like a differential pressure sensor that's going to measure our duct pressure and run 200 feet of wire between it and the air handler controller that it's tied to, it will suffer from something called voltage drop. Ted mentioned this when he was talking about our measurements. When we plug something in and start to draw current, because of the combination of the resistance of the wire and the amount of current we're drawing, we get a decrease in voltage. And, you know, when we're decreasing from 120 volts to 118 volts, because we plugged in a computer, do we care? Not usually. But when we're dealing with our small control signals, a difference of half a volt could be really significant, could make the accuracy of that measurement completely off. And our current-based control signals are immune to that. That's the biggest advantage to the 4 to 20 milliamp signal. And we use that mostly for sensors. There are a few actuators out there that will use it, though those are pretty uncommon anymore. And variable frequency drives still almost always have the ability to switch between our voltage-based signal and our current-based signal. Okay. Does that make sense? This is one of my vocal tics when I'm teaching. I ask for a lot of feedback. I ask for questions. I ask if that makes sense. So that's me. So, all right, Damien likes it.
I think that fact that in a series circuit that amperage is going to be the same throughout the circuit is a critical one.
Absolutely
Displays
true.
one.
So that is one of the other advantages that we rarely take advantage of, but we can, is we can put another device, reading device like a display or something, in series with a current-based control signal. So we could have an external monitor, maybe on the outside of a control cabinet, and we could monitor that signal without having to, you know, break open the circuit and take our measurements. It is an advantage. Again, not one we use very much anymore. We used to use it all the time back in the earlier days of electrical-based controls. And they still do massively in industrial applications where they call it instrumentation. All right. We'll move on, but when you got questions, ask them. And yes, I will continue to be annoying with saying that. Next up, we're starting to get into our signals where we are using digital means to give us an analog result. And the first for this is pulse counting. And the place we use this most is utility meters. A lot of water meters, a lot of gas meters will use pulse counting. So every time the dial goes around, it sends out a pulse to a control system. And when we know what that pulse means, maybe it means 50 gallons of water, we can start counting those pulses and totalize how much water we're using. Okay? We can average it over time with our modern systems, or we can just kind of keep track of it. You know, double check what the utilities water meter is telling us. Tell us if we've got a leak between their meter and ours. Okay, that's the most common place. We do still have some electrical meters that do this as well, though typically we are replacing those type of meters with something that gives us a little bit more information, because we're finding that we need that and can take advantage of that. The other way we use digital signals to make an analog in dealing with pulses is by measuring the amount of time a pulse is in the on state. So oftentimes this is averaged over 10 seconds. And, you know, if our signal is on for 5 seconds out of those 10, we know that that's a 50% signal. If it's on for 3 seconds, that's a 30% signal. The main place that we have used these for a long time is, again, variable frequency drives. Variable frequency drives are one of the smartest, most advanced devices that we connect to on a regular basis. But they've been around for a very long time, so they've built up a lot of utility, a lot of variability to make them as useful as possible. Mostly in our industry, pulse width modulation, really not that common anymore. We used to use it a lot back when control points were really expensive. We would use daughter boards that would break out a control signal, and we could control multiple digital devices with a single pulse width signal. Those were really popular back, again, in the early days of digital controls. And now we move on to our last example of digital to analog conversion as far as our actual inputs and outputs, and that's floating control. And we already talked about this. It's basically switching two different control signals most of the time to drive a device a certain amount of time. There is a big flaw with this type of control, especially when we're talking about actuators. Actuators right out the box will give you a time range that they hit. You know, most actuators, like our Belimo actuators, take 90 seconds to go from 0 to 100% open. Okay, that's what the box tells you. The reality is not usually that case. It may only take 72 or 80 seconds for it to get all that way. So you have to monitor that and calculate it so that you're getting an accurate position reading. And when you tell something you want it to be halfway open, it actually is halfway open instead of being greater than that. And there are some tricks that we use to make this more workable over time. You know, doing a nightly reset of the control or of the device to drive it all the way closed or all the way open. So we're starting from a known position. That's a really common thing to do, especially with VAV dampers. But we also have to take into account the fact that as these systems age, as the actuator ages, it gets weaker and will take longer. As these devices are in place longer, especially our valves and damper actuators, you know, the systems that they're interacting with, that valve or that damper, are going to build up more resistance over time as they wear out. So you have to monitor these and make sure that they're actually working where they should. And that's why in critical operations, we very rarely use floating control actuators anymore. We use our true analog signals. Okay. Our last control signal that we're going to talk about is resistance, our third electrical measurement. And we use this a lot to measure temperature specifically, using a device called a thermistor. So thermistors are just a resistor that is affected by temperature. It changes its resistance as the temperature it's exposed to changes. They are amazingly common in the climate controls industry because they're dirt cheap in comparison to any of our other options. An RTD or resistive temperature device, which is a very linear acting, long-lived, very reliable temperature measurement device, typically costs $100 or more. Whereas our thermistors are going to cost like $10. So there's a good reason we use it. And they're built to different standards. Problem is, they drift over time. So we have to keep up on our calibration with these and acknowledge that when our calibration gets far enough off, time to get rid of this one and get a new one. Okay. So, any questions on our control signals? Does all of that make some quantity of sense at least? I see Gene has a comment here in the chat. that one of their main problems is preventive maintenance on dampers and actuators. And yeah, absolutely, it's one of those things that you have to stay on top of. And monitoring your more critical spots for it has to be a priority. Monitoring your outside air dampers, monitoring your big hot water and chilled water control valves to make sure that they are operating correctly. A lot of these devices will cause problems for you when they don't, in such a way that you'll get alarms, or you'll know something's wrong and you have to go look at it. But sometimes your system will automatically compensate for these mechanical failures, and you'll actually never end up knowing about it. Leaking outside air dampers is a great example of this. Hot, humid weather, you're bringing in more air than you want. Cold weather, obviously you're bringing in cold air that you don't want.
Yeah. So I was going to mention, Robert, that, going back to this, all these signals, they're electrical signals, which is why we cover electricity basics quickly. And Aaron brought up in chat that there is this reverse, installation of the equipment where something's supposed to be all the way open and it's actually all the way closed. In his example, he just says 0 equals wide open. So we're looking at normally closed versus normally open type of actuators. And that's something that has to be checked.
Yep, absolutely. It happens all the time. Especially the bigger the building, the faster the build phase or the remodel was, the more likely you are to have more of these errors. And it can happen with floating actuators as well, where the signals are reversed, the open and the closed. And it can even happen when we are replacing an actuator that has been in place. It failed. We get a replacement actuator, we put it in place, and maybe we wire it wrong, or the model number has changed and you got an equivalent actuator, or it had a little set screw or something that you had to adjust for the direction. All those things definitely happen, and it's something to be watchful for, to be mindful of. They will, again, typically cause you some sort of a problem that's going to kind of wave its hand and say, hey, something's wrong, come fix me. But not always.
Yeah, I actually had that happen recently where new actuator installed. And we were commissioning the unit and we found it. So I know, I forget who mentioned it, but I think it was either Lindsay or Melissa mentioned that they're doing some continuous commissioning, and continuous commissioning will tend to pull that type of thing out, because you're going to, in this case, a damper actuator for outside air. You're going to end up seeing that the damper actuator is actually closed during the occupied period and open during unoccupied. So there's repercussions of not doing that type of work that go beyond just wasting energy, potentially.
Yeah.
So.
And you also have to be careful when you're doing these replacements, because sometimes we do want the valve or damper to be open when it has a 0 volt signal. That is not an uncommon thing, especially things like our return air dampers. When they get a 0 volt signal, typically we want those to be open because it's a safer state. Or having our hot water valve fail to an open state, especially in the colder climate zones. So it's something you have to be watchful for. And if you have access to the control drawings for your building, it should be noted on each of those devices, or each of those actuators, as to what type of signal it's getting. But it also behooves us then, anytime we are replacing something or repairing something, to test those type of devices. And when we say commissioning, one of the aspects of that is testing. So testing calibrations, testing the action on an actuator or on a relay to make sure that it's working properly. And especially if you're already at a piece of equipment doing something, you know, probably more significant than changing your filters, doing a yearly PM or something like that, this should be one of the things that you do. Not saying that we necessarily have the time to do it every time, but it's one of those should items. Other questions on or comments on our control signals or the devices that use them? All right. Next slide, please, Ted. All right. So we already talked a little bit about it. On our input side, we have sensors, right? That's what they are. That's what we call them, whether we're measuring temperature or position or anything like that. We call them a sensor, or it's a feedback signal from another device. Can be a variety, can be analog, can be digital, can use our different control signals. That's a sensor. On the output side, we have actuators. And note here that I've got a footnote that this is the technical definition of an actuator. And it uses an output signal from the controller and modifies the conditions measured by a sensor. So it makes a real world change. Okay, does that make sense? Sensors measuring the real world, actuators affecting the real world. Inputs, sensors, outputs, actuators. Right? And I imagine that some of you caught on to that technical definition. Next slide, please, Ted. So, is a relay a sensor or an actuator? And yes, I absolutely expect there to be some fight on this conversation. Damien says a relay is an actuator. Anybody else? Troy agrees. We're at an actuator. Somebody liked Troy. There we go. Tyler's on the same boat. Melissa says both. I got to be careful here. Okay, I just had to check the wiring diagram on this rib. So there are especially some relays where we do get feedback from them, current sensing relays. It's a switch, so it's an actuator. We control the output, Gene. Yep. And Aaron agrees, actuator. So we're mostly agreed here. Melissa absolutely has a point. Sometimes our relays can be both. They can be a sensor and an actuator. I am surprised, though. We didn't have much of a fight on this one. Most of the time, people are going to say, it's not either of those. It's a relay. It's a different thing. Because
somebody said today.
Yeah. So if we hit the next slide, we run into our practical definition of actuators. Most of the time, we're not going to call a relay or a motor starter an actuator. We're going to call it what it is, a relay or a motor starter or a contactor. Okay. We could even say that a VFD is a type of actuator because we are making changes to the real world. But practically speaking, when we talk about an actuator, we're talking about a device like in the bottom right-hand corner there. We're talking about something that moves a valve or a damper most of the time. There are other times we use actuators as well, but most of the time, 99% of it or better, we're going to move valves and we're going to move dampers. Okay, these are two examples of common actuators. Those Bellimos have been an industry standard for a very long time. And no, I'm not looking for any debate from you Siemens or Johnson guys. Everybody else in the world agrees Bellimos are good. I'm just teasing. I really don't have a strong opinion on that, but it's fun to poke the bear. And those old Honeywell actuators, the metal block type ones, have been in use in rooftop units and makeup air units for decades, and they still are. Okay, so our actuators come in a variety of flavors. Typically, in modern systems, we're going to either be dealing with electromechanical, which is what we have here on both of these, or pneumatic. Okay, those are the most common that we run into, but there are others. For any of you who are still running steam systems, you probably have some of the old wax-based actuators that are controlling steam valves. They're fantastic. They work seemingly forever until they don't. The thermostat in your internal combustion engine works on the same idea. Okay, but there are other types. There are pneumatic, there are hydraulic actuators. They all have their specific uses. But again, most of what we're going to see is electromechanical and then pneumatic. Older buildings that have non-updated systems, you see a lot of pneumatics. Modern buildings, you don't see a lot of pneumatics. Their control options typically fall into two categories. You have modulating actuators, and these are our actuators that can be anywhere from fully closed to fully open, or 0 to 90 degrees, or I don't know, 96 degrees, 95 degrees, whatever their maximum position is. And they can live anywhere in between, depending on that control signal. We use the word proportional for those that are controlled by a voltage or current-based signal. And we use the term floating for those that are, using a digital signal to get an analog result. And I'm sure many of you have heard the term spring return in reference to actuators. Again, especially when we're talking about things like outside air, return air, and hot water valves, where we want, no matter what happens, power dies to the building, we want the building to be in a safe state. So we close off the outside air damper and open up the return air damper and open up the hot water valve so we don't have to worry about things freezing. Okay. Spring return does work on proportional actuators. Not all proportional actuators are spring return. But floating actuators are not spring return. It defeats the purpose of the floating actuator. It becomes too expensive to implement as a floating actuator, at least most of the time. We do also have two-position actuators. We use these a lot on things like exhaust fans to isolate them so that we don't have backdraft air coming through when they're in the off position or not running. So we use two-position actuators. We will do this a lot on flow control valves where we just need to have all or nothing so that we can, maybe we have a two-pipe system within our building where we're sharing the piping between hot water and chilled water, and we use it based on the season. But we have the ability to swap between the two back at the boiler or chiller. So we're not running our water through the other device during off times. Those are oftentimes when we use two-position actuators. Zone control systems in older buildings or a lot in repurposed residential systems were two-position. And to position is almost always also spring return, because it's cheap. We just send it an on signal when we want it to open or sometimes close, and we let the spring drive it back to its natural state, or its default state, or its normal state. Okay. Any questions on sensors or actuators? All right. So, next slide, please, Ted. We are on to talking about our building system architecture. So we're talking specifically mechanical systems and control systems here. I'm not trying to talk about architecture. I don't have knowledge in that area, and I will not lie to you and pretend that I do. Okay, we're talking mechanical systems and control systems here. So, next slide, please, Ted. We're going to start off on the controls side. So we've got a pyramid here on the left because really that's how things are in our building. We start with, at the bottom of the pyramid, with sensors and actuators. This is where we're really doing the work, right? We're measuring the conditions, we're modifying the conditions. We're measuring the conditions, we're modifying the conditions. And because of that, we have, in most buildings, hundreds of sensors and hundreds of actuators, especially when we're using that technical definition of actuator and counting our relays, right? Even a fairly small building has a whole lot of sensors and actuators, right? And the more modern the building is, the more of them it has. Okay. Well, the vast majority of these sensors and actuators report up to our zone controllers or our unitary controllers. These, we could have hundreds of these types of controllers in larger buildings, or we may only have, a couple of dozen of them. But they're the second most common thing that we have. Above that, we have our plant controllers. So these are what's going to control the large equipment. These are going to control our chillers and boilers and their associated pumps, cooling towers, heat exchangers, control valves, etc., etc. Also, we're typically going to find our plant controllers at our big air distribution devices, like our air handlers, and maybe on our rooftop units. Though sometimes the rooftop units may have factory controls that don't tie directly into our control system. But still, we generally call those plant controllers. And then we have our building controller. Typically, we have one of these per building, or maybe a couple on big buildings. And these report directly up to our servers. And hopefully, especially those of you with large districts, you have a fairly limited number of servers that it's reporting to. Most of the time when we have good building level controllers and good networking architecture, we can have, 15, 20, or even 100 controllers or more, building level controllers reporting up to a single server or single server system. So that's why we've got it set up in a pyramid, and it really is very effective at describing our common system architecture. Okay. Does that make sense to
point here too, Robert, that you mentioned sensors and actuators are at that lower level, and sensors kind of report up to unitary zone controllers. And you mentioned there are exceptions. One of those exceptions that I've seen are outside air sensors will oftentimes go in at either a plant controller or building controller level to provide a uniform outside air temperature to a vast array of different pieces of equipment.
Absolutely right, Ted. And just because the plant controllers have that layer of unitary and zone between them does not mean that we don't have sensors or actuators directly wired to those. We
Yeah.
can have those wired directly to plant controllers, or even some of our building level controllers allow that sort as well. And oftentimes there will be data that goes back down the pyramid as well. Things like occupancy schedules, for one, it come down from higher up. Our plant controllers may pass data as to whether our hot water or chilled water system is operating, or the discharge air temperature coming from the air handler, so that our zone controllers, our VAVs, can make some decisions based on that. It may affect their sequence of operation. Other comments or questions? All right. Next slide, please, Tim. All right. So again, this is more talking about our architecture here, more the verbal side of it versus the visual side. We have lots of sensors and actuators that are connected via low voltage cabling, typically, to our unitary or zone controllers or our plant controllers. Our individual controllers are normally connected to each other in a small network. If we're working in older buildings, then we're going to use low voltage cabling, often MSTP, which stands for Master Slave Token Passing, which is an electrical engineering standard. But it's a 2-wire cable. I'm sure a lot of you have a lot of this in your system, whether you're dealing with BACnet or one of the proprietary communication protocols like Johnson Controls' old N2, or for those of you dealing with kind of the Network 8000 or the old Andover Infinet standards. It used to be the case where almost every company had their own proprietary network, but the vast majority of them were built off of the MSTP standards. Also, of course, I heard it earlier that at least some of you are still running LON, L-O-N communication, or Echelon is the full name. Again, older systems, this was a 2-wire communication protocol, and it was a competitor to the MSTP standards, and was a very big usage in trying to open up our communications between companies back before BACnet became big in the United States. BACnet, of course, is a standard that was created by ASHRAE, the Association of Heating and Refrigeration and Air Conditioning Engineers. Our more modern control systems are starting to move away from this MSTP 2-wire type cabling and moving towards a proper IP network, or Cat5 or Cat6 Ethernet. This is more common in newer controls, but it is not exclusive by any means. A lot of daisy chain type connections in this situation, whether we're dealing with MSTP or IP. Next up, of course, we have our plant controllers. Our plant controllers for a long time have largely been on the IP network, or IT network if you'd prefer, using Cat5 or Cat6 Ethernet. And oftentimes will act as a gateway to the zone or unitary controllers that are below it. For example, you would have your VAV controllers wired on an MSTP trunk or network that would then connect to your plant controller for that given air handler. So it was all kind of in a tight bunch for its communication needs. There are still some plant controllers that live on an MSTP side of the network. A lot of companies still sell that as an option, but not many people are using it in newer buildings because we're trying to get more data and more reliability out of our communications. So we've kind of moved away from that. Again, there are still companies that do it. ALC, I know, is one. I know Honeywell moved away from it a while ago. Schneider moved away from it a while ago. But they still have controllers that are kind of bordering that plant level controller line. And of course, we have our building level controllers. Our building level controllers connected to the owner's network typically, the IT network, and pass their data up to the servers via that. They may be directly connected to the MSTP networks down below it, or they may be connected just via the owner's network and pulling that data across. It really depends on how the system was designed. There are times in more high security facilities where they're more concerned about their networking data, that you may still have a completely separate controls network that does not have access to the owner's data network, and there may be no outside access, and you have to physically go there. This is the way a lot of our systems used to be, but it's pretty uncommon anymore. Troy adds the comment that that their vendors like to offer cloud-based services or servers. And yeah, that is something that is gaining in popularity within the industry. Whether you are, I know Train likes to do that with theirs, but just about everybody offers an analytics service now that is a cloud-based service. And it's a discussion that you have to have with your vendors as to whether that's an advantage to you or not. There are a lot of concerns about data ownership in those situations and data security that are all very valid concerns. But in most situations with those cloud-based servers, you get advantages towards accessibility for your technicians. You get a alarm at 8 o'clock at night and you can just remote into the system and check it out and kind of put a band-aid on it until the morning when you can go and physically do it so that you're not spending a bunch of time on overtime. Maybe when you can't even get parts to fix it anyway. But there's also a lot of times additional analytics. They can tell you about your energy usage. Maybe it can perform that automated commissioning or continuous commissioning task. So there are advantages and there are disadvantages. Ongoing cost is definitely one of those common disadvantages. Other questions about our building system architecture for controls?
Well, Robert, you mentioned that it's easy to access the cloud-based servers. That typically is true for your own VM, your virtual machines that you have, right? They're typically pretty easy to access, or do you have to go through some type of gateway to it?
That really depends on the system and how it is set up in a building. And a lot of that is actually driven by IT. For a long time in building controls, our systems were completely isolated. And if you wanted to look at that building system, you had to go there and physically be in place in front of their server in that building. As time went on, we started tying it to the owner's network, and we gained some remote access to that. A lot of times it was just accessible by the controls vendor and the internal staff personnel. But a lot of times it was just effectively a public web page if you knew where to look. Obviously that had some security concerns and eventually some usability concerns as we had more negative intent actors out on the internet. So we started to lock those down, and nowadays it's much more common for remote access to come through a secure connection, some sort of VPN, virtual
Well, no,
private
I've said
network. But
in the
depending
ad
on your IT system and how they have it implemented, that could be really hard to access or have a lot of paperwork to get the access set up originally. It can be unstable depending on how effective your IT department is at managing that particular system. And sometimes, if your facility is a higher security facility, they may just say, no, we're not doing that. A lot of military and government facilities take that route. For a short time, I did service for Union Pacific Railroad, and to get onto their VPN, one did take a lot of paperwork, but they had specific key generators. This was back before things like Google Authenticator existed. And so you had to have a little key fob that you would press and get a code. So it really depended on the security level that mostly IT wanted to maintain.
I know for our VPN that I use, they time it out after a certain time, it drops me off.
Yeah.
If I'm on it or not, doesn't matter. That's probably just a very specific thing to way that our IT department has set up.
And when you're a controls vendor, one of the challenges is actually that remote access piece and managing it. If you're managing multiple sites from different companies, you may have a different VPN service that you use for each of them. Another thing that has started to be done a lot more recently is the control vendors themselves will leave a VPN brick that's basically a small computer that has a very secure connection into your system specifically for troubleshooting purposes. Sometimes it's tied to an IT network. Sometimes it's a completely separate 5G device. And a lot of the equipment manufacturers that are making the more expensive stuff have started to go with that 5G remote access as well. Big chillers, Train chillers, I know they do it, Daikin does it. If anybody has any of the modern Aeon brand rooftop units, they like to do that with their units so that their tech support can literally just connect to the unit to help the technician diagnose problems. Adam made the comment that he's found vendors trying to install a program called TeamViewer onto their servers or their controls workstations. And yeah, that was a common solution that we used for a long time. It and other tools like it that basically set up a unmanaged remote connection to devices. It was a go-to tool for a long time. And again, really useful, but posed some very significant security concerns. Yeah. And it's always one of those things with any of these systems, it's a balancing act between convenience and security. The most secure system in the world has no connection to the internet or any other part of the network, but it sure is hard to get to in those situations. Justin suggests regularly incentivizing cooperation with your IT department by buying them donuts.
I like that idea.
It's a good rule of thumb. I like that one, Justin. Oh, don't worry, Adam. We'll talk about BACnet, but it won't be today. Yeah. Anyway. Other questions and comments? All right. Let's go ahead and jump to our next slide, Ted. Now we're going to start talking, nope, this is just an enlarged picture that we had on that last one. We can see our field controllers connecting to our sensors and actuators down at the bottom, feeding data up, in this case, through a BACnet MSTP network or two-wire network, to our supervisory controller, or what I was referring to as the building level controller, and up into our IP level network, talking to our servers and our workstations. This is a little bit outdated of a modality for this, but it's still really applicable. And unless you have a system that was installed in the last handful of years, probably really applies to a lot of you. I agree with you, Adam. Adam is continuing to talk about the security of our IT networks, of our building control networks, and how they should be, the traffic should be separated out so that there isn't conflicts or access to other data. And yes, he's absolutely right, it should be. And in modern systems, sometimes it is, sometimes it isn't. Older systems, oftentimes it wasn't, and it did cause problems. All right, next slide. So now we're going to start talking about the building system architecture of our mechanical systems. So down at our base level, most buildings have a single plant. So this is going to be talking about our hydronic systems most of the time. So things like our boilers and chillers and the associated pumps. Can include things like heat exchangers, cooling towers, and control valves. Fluid coolers and dry coolers and cooling towers are all very related devices, just slightly different, but they reject heat from the building. That's what they all do. That's what their purpose is. Okay. These are one of the places you'll typically refer to as a mechanical room. And I'm sure, given most of your background, that this is a very familiar term and set of equipment for you. A lot of money in these rooms, a lot of equipment. And again, this is going to tie back to what we refer to as plant controllers. Okay. Bigger the building, the bigger the plant. And again, most buildings have a single plant. Really big buildings may choose to separate their plants from chilled water and hot water. Some will combine them. Some will have multiple plants because the buildings used to be two buildings and got remodeled and attached together at some point. Sometimes you will have a separate plant that provides an entire campus with hot water and chilled water, or a water loop for water source devices. Okay. Pretty standard stuff though, right? But again, not all buildings have to have a plant. Next slide, please, Ted. Okay, step down in size and more common, or more locations typically, is our big air distribution devices. So these are our air handlers or our rooftop units. These are the things that are going to provide, you know, thousands of CFM of air to various places throughout our building, or sometimes just serve large single zones. Cafeterias, gymnasiums, auditoriums oftentimes will have a dedicated unit specifically for those locations, because it just requires so much air that it just makes sense for it to have its own complete system. And in some areas, it may be an energy code result as to why you get a specific air handler, especially for like your gymnasiums. I know for a long time in the state of Wyoming, it was against the energy code and local codes to install any kind of air conditioning for a gymnasium. Go figure. Okay. But again, chances are you're probably going to have multiple of these within your building. If you've got a big building, it may be, somewhere around 10 or more. If you have a smaller building, chances are you're in the single digits. But it really depends on how the system was designed. And especially when we're talking about rooftop units and how they may end up serving single zones instead of serving the devices that serve those zones. Next slide. And of course, then we get to the zone controls. And again, a rooftop unit or an air handler can act in the capability of doing a specific or controlling a specific zone. Though most of the time we're going to relegate that to being for our larger areas, high volume areas, high heat areas. Sometimes our kitchens will end up that way. Typically, when we're talking about zone controls, we're talking about the things that control like classrooms, especially classrooms, offices, places like that. On the air distribution dependent side, so these have to be connected back to an air handler or rooftop unit that supplies them with the majority of their air. We have the category of devices called air terminal units, or ATUs. And there are a number of different types underneath this. In modern buildings, our most common is, debatably most common, is the VAV box, or variable air volume. These have a control damper that just modulates the amount of air coming from the air handler that goes into the space. They may or may not also have reheat capabilities. So they may have a hot water coil, a steam coil, or an electric heating coil. Those are all, I won't say necessarily common options, but they're all possibilities. Okay. A step less common than that in most modern buildings is our constant air volume boxes. These will oftentimes have a damper that controls to maintain just a constant amount of air. Doesn't matter rain or shine, summer, winter, it's going to always put out, or it's going to try to always put out the same quantity of air. We don't see a lot of these because they are typically inefficient in comparison to our variable volume boxes. They don't keep as good of temperature regulation for the space, and they use more energy in doing so. Again, they may or may not have reheat capabilities. We have our fan-powered boxes. These were popular and still are popular in some instances. They have a fan that can move air in addition to getting air from its air handler supply. So there are some advantages to these. There are some disadvantages to these. The big advantage is at night, at least with a parallel fan-powered box that draws return air from the space, is it doesn't have to wake up the air handler to keep the space warm in a cold on a cold winter's night. But they have a lot of maintenance associated with them. They have filters that have to be changed on a regular basis. They have fan motors that may or may not need maintenance attention, but inevitably will fail. And like most things that live up in the ceiling, when you go to do work on them, somebody has put a desk or a big piece of equipment right where you need to put your ladder. At least that's been my personal experience. So maintenance on them, challenging. Okay. And in ages past, we used devices called dual duct boxes. And these were devices that used a pair of dampers, one that controlled the flow of cold air and one that controlled the flow of hot air. And they worked in conjunction. Basically, your hot air replaced your need to have a reheat coil at that zone control device. But these have fallen by the wayside. They are very uncommon to find them in new buildings, as they are more costly overall than a VAV with a reheat coil. So we just don't see them very often. But again, depending on how old the buildings you are that you're dealing with, you may have these. They still make controllers that deal with them. Oftentimes they are a specific control model that has the ability to deal with the twin dampers and sometimes airflow sensors. Most of all of these have airflow sensors at that damper, so they know how much air they're putting out. Not always the case, but most of the time it is. And those do need to be calibrated when the system is first installed, and they need to be recalibrated over the life of the system. Keep that in mind. Okay. And yes, I do see your comments there, Troy. Yes, we will talk about VRF here in just a minute. Yeah, and I'm not surprised to hear that you're removing most of your fan-powered boxes or fan tube boxes and dual duct systems. That's pretty common. Dual duct, or I'm sorry, fan-powered boxes were really popular for quite a while in high-rise construction, because you could put fan-powered boxes around the outside perimeter of a floor, and it would take care of its heating in the wintertime for that area. And then you would just put in VAV boxes with no reheat coil in the middle of the building because you didn't need that reheat capability. Of course, if we have air distribution dependent, then we're probably going to have some independence as well. And given that you all are schools, I'm sure more than a few of you run into these because they are pretty popular solutions for schools. So we've got our fan coil units. That's what we actually have depicted here on the left. This is based in many cases a miniature air handler, oftentimes hidden in a closet or up in a ceiling. It has, a lot of times it will have hot water and chilled water coils and a fan associated. So it may just have hot water, or it may just have chilled water as well. Sometimes we'll see these in mechanical rooms to deal with excess heat load, and it'll only have a chilled water coil. So they're pretty common. They suffer a lot of the same maintenance issues that our fan-powered boxes do, but they do have the advantage that they don't need to pull air from an air handler. So that can be a benefit.
I have a question for you, Robert.
By
You
the
know,
way,
as far as- you've mentioned a couple times, you know, with the fan power boxes and with these fan coil units that they have the maintenance issue associated with them. Is this generally just because now you have more pieces of equipment that have fans and extra motors and valves on them? Or is it because they're inherently bad from a maintenance standpoint?
yes to both. Mostly it's the first. Mostly it's just because you have more fans, more filters to change, things like that. So it is more work. But a lot of the times when these are put into ceiling spaces, then it's also hard to access. So it
Right.
makes them doing that maintenance harder. Most of the time, our big equipment like air handlers or rooftop units has accessibility in mind with its placement. Not always. I've definitely worked on some air handlers that I felt really sorry for the building maintenance staff to deal with. But most of the time, they're intended to be accessible. A lot of times our fan coil units, fan powered boxes, when they're shoved up into a ceiling, it may be intended that they're accessible, but that doesn't mean that the electrician that came in afterwards agreed with that need of accessibility. And sometimes you'll have electrical conduits or plumbing pipe or hot water or chilled water piping or fire sprinkler piping that's in the way of where you need to go.
Or you simply have an installer who didn't follow the drawings.
That's never happened, Ted. Installers always follow the drawings, and nobody ever puts a piece of equipment flat smack against a wall and has the side that needs to be accessed right up against that wall. That never happens.
Never seen that.
Anyway, sorry. Hi, my name is Robert. I have opinions. All right. Anyway, we also have closely related to our fan coil units. By the way, oftentimes one of the things that defines a fan coil unit generally is that it actually doesn't have any fresh air intake. That's one of the things that separates a fan coil unit from a small air handler. So we don't have those, the ability to affect our indoor air quality nearly to the extent that we do with some of our other systems. Unit ventilators. Yep, if you've got these, you know what they are, and you probably don't like them. Unit ventilators are the devices that we often find lining the wall, lining an outside wall underneath the windows. They blow air in a general upwards direction out into the room and suck it in down at the floor level.
And they will have the outside air intake going through the wall.
And often have that outside air intake going through the wall. These
Which I've
are
seen a number of schools with that, and because it's pretty prevalent here in Wisconsin, at least it used to be. And I've seen landscaping or maintenance crews spraying pest control or weed control a couple minutes before classes start on a weekday morning, right underneath where those intakes are. Indoor air quality issue, something to be concerned about.
Yep. And, you know, as Ted intimated there, generally speaking, we don't like these. They are basically an air handler in a very tight, small box. It has all of the complications of an air handler. We have outside air, we have hot water, chilled water coils. So if we're in a cold climate, we have to worry about the coils freezing. We have indoor air quality issues because, again, the air intake is right at ground level most of the time. So we have problems with picking up dirt and dust and the things that get sprayed on the outside or near the outside of the building. We have, if it's near a public or a street of any kind with traffic, we get a lot of air pollution from the vehicles. They're just not great for us. They still have fans that fail. They still have filters that need to be changed. And additionally, most of the time, the teachers don't like them either because it's a noise source within the space. At least the older ones. I've been told that the newer ones that use ECM, electronically commutated motors, are quieter. I'll believe that when I see it. But in theory, they are better. But they are a reasonable budget solution. They are a way that we can modify an existing school that did not have air conditioning before. For example, maybe they only had hot water radiators along the walls. You can put in unit ventilators at a very reasonable cost to add air conditioning to a school. That's where I dealt with them the most, was exactly those situations. So they do serve a purpose. They're just kind of universally disliked. In a similar capacity to fan coil units, we have unit heaters or cabinet unit heaters. These are typically the kind of devices that we find in vestibules that to provide heat in those spaces during the winter time. I don't know if we use them very much down in the South where it would make sense for them to be cooling devices. I think air curtains are more popular in those situations. But it's basically a fan and a reheat coil. Sometimes the reheat coil has a valve, sometimes it doesn't. Sometimes you have direct control of the fan, sometimes you don't. They can be controlled seasonally so that they're enabled all winter long and just run all out. Sometimes you'll have control of the fan and the coil just runs all the time. Sometimes you'll have control of the coil. You'll have a valve on the coil, and when the coil's hot, it uses a thermostat type sensor to turn the fan on. Okay. Really common. Usually you end up with a handful of these throughout a building in the northern parts of the country. And last up on our mostly distribution independent systems is our heat pumps. Okay, these can be anything from a near residential grade heat pump with the indoor component hiding in a closet or above a ceiling and has an outdoor component that's acting as the evaporator or condenser depending on your function. Or they can be a water source device, so pulling water directly from the plant to either absorb or reject heat. Water source heat pumps I know are really popular here in the central Midwest, especially kind of Nebraska, Kansas, Oklahoma, kind of that area, because they can be really effective. And they can be paired with a geothermal loop, but they don't have to be. Really depends on the system design. A lot of maintenance, but from an energy efficiency standpoint, they're pretty stinking good. So, advantages and disadvantages. Next slide, Ted. All right, so here's the other systems that we run into. And I did miss one on this list. So we'll hit it right at the beginning. Exhaust fans. We control most of our exhaust fans within a building anymore. It used to be we would have exhaust fans that would just run 24/7 or run off the occupied schedule or had manual controls. Most of the time anymore, we control them directly. That way we can monitor them for failures. We can run them when we need them so that we're not wasting that energy. Oftentimes associated with those exhaust fans are makeup air units, abbreviated MUA or MAU, depending on your area of the country and what engineer you're working with. These are predominantly 100% outside air units, providing replacement air for those exhaust fans. We often find them paired up in kitchen control situations where we have big exhaust hoods because of the equipment. But they oftentimes act again as very similarly to air handlers. They may maintain a discharge air temperature or not. Oftentimes they will use a lot of natural gas, gas pack burner systems to heat up that air, or DX cooling for those as well, if you're in a part of the country that allows DX cooling on makeup air. Mini splits. We've seen these before. We've seen these for a long time. Elevator rooms, electrical equipment rooms. Used to be we saw these in networking closets and server closets, especially in schools back in the day. A lot of times we've upgraded those systems now, but they're still very common. A lot of code around, especially things like elevator rooms, require usage of these type systems. They make them in a heat pump variety now, but most of the time when we're using them in commercial buildings, we're just using them as a cooling only application. We also used them a lot when we were first starting to add computer labs to schools. And we would put the big 4-foot by 4-foot cassette up in the middle of the ceiling in the converted classroom that became a computer lab to add the cooling that was needed so that you didn't bake poor students' brains. Split systems. These are basically residential systems that were applied into a commercial environment. And that's not as uncommon as you would think. I have seen systems that were gas-fired furnaces and a 12-SEER air conditioner installed in school buildings. A lot of times they will stick it into the classroom and it will be just like fan coil unit or heat pump hiding in the closet. Very, I won't say normal to see, but I've seen it happen. Modern systems, we are starting to see variable refrigerant flow. I don't know how much we are seeing it in schools because it is kind of an expensive solution to install, but it does exist. Okay. So if you're not familiar with variable refrigerant flow, it is what we've kind of got the picture of here on the left, where we have multiple mini split units that are tied back to a single condensing system. Sometimes that is an outdoor system, very large looking condenser, or sometimes it's an internal system that looks more like a water source heat pump and operates like a water source heat pump. Pretty much relegated to newer buildings. And these systems almost exclusively will have their own dedicated control system. It's something that you're going to communicate with like you would pull data out of a chiller or a package rooftop unit with factory controls. So the data you may want, you may not have access to. So there are advantages and disadvantages to these systems. They can be very energy efficient, and if they're installed properly, they can last a long time. But if they're not installed properly, they can be an absolute nightmare from maintenance and operations. So it's one of those, if you've got one of these systems, you know about it. If you don't have one of these types of systems, I would encourage you to read up on them, because if you get a new building, somebody's going to be talking about this. Whether it's within your school's systems budget or not, that I don't know, but I'm sure it will at least be discussed. Okay. Yeah, and there are a couple folks here in the chat that are saying they do have these systems. Very problematic to troubleshoot and deal with. Very little support from manufacturer. And yeah, unfortunately, that's been my experience too. Just like with mini splits, when there's a problem with it, they want you to just replace it. And with a mini split, when you're only spending a couple $1,000s, that's one thing. When you're looking at the entirety of a system where you may be spending hundreds of thousands of dollars to replace it, that's a whole different conversation. But is what it is. I guarantee we will see more of these systems. It's just a matter of where, and to advocate, if you do get one, that the installation is absolutely perfectly done. And to really be on your contractors, if you get one of these systems, be on your contractor during the warranty period to stamp out any issues you've got. Okay, that's one of those places where you really have to be the advocate for yourself, is getting the warranty stuff handled correctly and rapidly. Okay. And one of those things that we do see, not VRF, but PTAC units, package terminal air conditioners. These are those types that we see shoved through a hole in the wall. They're basically, most of the time, a heat pump. Sometimes they have some heating strips. Sometimes they don't. Place I'm most familiar seeing these is hotels, but they're used in schools too. Again, one of those things, if you've got them, you know about it. There is not a lot of control interaction with these. They're pretty much set up as standalone units, unless you have a thermostat system that ties back to your controls. But again, they do exist. We also have radiant systems within buildings, ceiling panels. This is typically more with a heating type system. So we're going to have hot water panels in ceilings, sometimes in walls. We can have in-floor radiant heat. Keep the students' tootsies warm all winter long. Snow melt systems outside so you don't have to go and shovel. Those are fantastic when they work, and when they fail, they are definitely not considered a priority repair item. At least that's, again, been my experience. And of course, we have the classic radiators. This could be just kind of perimeter heat to augment the heat being put out by one of the more zone control systems, to work in conjunction with it. Or again, older buildings, it may be all you've got. So, and it would be an appropriate one for those systems where you don't necessarily have any need for air conditioning. I could see where we would just use radiators. Could be steam, could be hot water. They still make both. And of course, we already talked about exhaust fans. All right. Next slide, Ted.
Questions?
All right. Questions specifically for right this second about any of our control system architecture or mechanical system architecture, so we can get those out while we are fresh. I'm just catching up on the chat here. Yeah.
I think you've been hitting it all, Robert.
What's that?
I think you've been hitting it pretty well along the way here.
Fantastic. I see Troy's got a comment here about nervousness about flammable refrigerants in new buildings. That's one of those downsides to the variable refrigerant flow systems, or variable refrigerant volume. To be fair, one of those is a copyrighted term, and I don't ever remember which. Is that you do have refrigerant flowing throughout your building. And yes, with the modern series of refrigerants, the new A2Ls, that are coming into play, which are slightly flammable refrigerants, that's a reasonable concern about a potential refrigerant leak. So I completely see and hear you there. I haven't seen any VRF systems that are running the A2Ls yet. I think most of them are still kind of sticking towards the 134A type refrigerants. But any sort of refrigerant leak in that kind of situation can be, one, challenging, and two, problematic. So. All right. Other questions about anything we have covered so far today? We have just a couple more slides, but literally it's, I think, 3 more after this. So we're almost done. Sorry, 5 more slides. Troy.
I was just going to mention something about, like, I mean, it's easy for me to embrace, you know, these systems and everything, and all the sensors and data and, you know, control over everything. Because I've kind of come up through it a little bit more, sort of like you probably. And, you know, having a chiller plant, providing chilled water to my air handlers and having the VAVs and, you know, outside airflow stations and, you know, having all the bells and whistles and alarm points and all that kind of stuff. I'm comfortable with, but I do have some people that I work with that are kind of getting nervous that we're becoming like too dependent on all these sensors and all these controls, and that it might be smart to go back to a more simplistic kind of way of operating, like that we're, you know, relying on airflow stations and humidity sensors and CO2 sensors and, you know, so much, like, I mean, whatever, occupancy sensors, and that we're becoming so reliant on everything, almost like a self-driving car, you know, like, would you put your life on the road with a self-driving car, knowing how flaky sensors and things like that could be? So I'm just curious what your thoughts are on that. Like I know one of the guys that works for me, I guess, or on my team, I should say, you know, would kind of like to see outside air more just almost set up like a constant volume. You turn it on, you turn it off, and get away from relying on all the dampers and airflow stations and everything else. He just kind of gets a little nervous that we're so dependent on all this, and that we could really save a lot more if we weren't, you know, the IT and all this stuff, you know. And it's like, I mean, I see where it's going, and I'm kind of on board with it, but anyhow, I'm just curious what your perspective is on that.
Yeah, so I came into it from controls, so I'm all for controls by default. I'm not saying that your associate doesn't have a solid point, that the more complicated the systems are, the more challenging they are to properly operate and maintain. So I 100% get that. And it's part of why I'm a very, very big advocate for trainings like this, because you don't know what you don't know. And we do an absolutely horrendous job on training around building automation systems. Not just training people to operate the systems effectively, but we also do a terrible job of training people to install it. So it does result in some really challenging circumstances. But that being said, as our energy standards, as our air quality standards, as all of that tightens down, because we've done studies that acknowledge that the less CO2 in a space, the more aware and cognizant people will be, the better students learn, the more productive people are in an office or production environment. We know those types of things affect. And the only way we can realistically do that without hiring an absolute ton of people to manually do it is through control systems and through sensors. Do we need to do a better job of training how to operate and maintain and install those systems? Yes, absolutely. Do we need to work to maintain or to build systems initially that are more robust, that are more error tolerant? Yes, we do. But will we see systems being specified with less of the automatic controls? No, we won't.
I don't see how it's possible as things continue to grow to avoid it, honestly.
It's not.
Like, I mean, what are you gonna just have all analog manual controls and someone physically flipping them on? Like that's insane. I don't see how that's even possible. And I'm not just being biased because I'm in IT. I definitely see the detriments of Internet of Things and all that, and integrating all these things without considering traditional best IT practices. But at the same time, like, I don't know, coming over to facilities, I definitely see like a barrier to technology. And like a lot of that, I don't think it's lack of skill. I just think it's their mentality that they don't want to deal with it and learn new things because it's, like you said, not the way how things have been done in the past.
And it's change. People are resistant to change quite often, and our industry is, at least the building industry, at our base level is like that. And
I just don't see the alternative. I mean, you're going to have analog sensors. You can have a bunch of mercury sitting around. Like I don't get it. I'm sorry. I didn't mean to be rude or anything. I don't understand how they can think that we have a choice at this point. I mean, I'm the only energy man. I'm a one-man show here. So I don't have the manpower to physically go around or schedule, stuff outside of our occupied times and adjust things at the site with a laptop connected to it through a serial connection. Like that's crazy.
Yeah, I mean, I'm on the same board. I mean, I think I'm coming from the same perspective as you guys. And I don't think that, like the people that I have that are on my team that like they came up through the industry too. They're not, I don't think that they're necessarily afraid of change or anything like that. I think they just see like how failed sensors that we don't notice sometimes keep campuses on like running 24/7 for days and weeks and months on end. And then you start to see the cost of some of the components. Like each thermostat might be $500 now, because it's a touch screen and it's color and, and it's almost more liable to be broken or something. And then, I'm going to date myself a little bit because when I first started as an energy manager with the district, the person that I was working for at the time talked about a nearby county that used to use twist timers in every classroom, instead of, any sort of building automation. And he was like, they had some of the best efficiencies because, they twist the timer and it runs and it's almost perfect occupancy sensor, I mean, they're going to keep that timer twisted to maintain the cooling for the time that they're in the space. So, here we are putting all these fancy components in to capture, movement in the classroom or sense the occupancy. And anyhow, I'm sort of playing devil's advocate, I guess, to a degree, but I mean, I'm not disagreeing with everything you're presenting because I mean, we have it and we've adopted it, but there is a philosophy there on my team that kind of wishes that we could simplify some things and we weren't, all in with everything that sparkles or flashes.
And sometimes simpler solutions are better. And it's one of those things of common sense sometimes should still win. But we got to kind of temper that to some extent too. But I'm not saying that they're not valid concerns because they definitely are.
And I think Adam's point is valid that there's just no stopping this. This train is coming. It is here. It keeps moving. We see it in all aspects of our life. And it's just something that we have to grow work with. So.
Now, like I said, we do still have a couple of slides to go. So to be cognizant again of your time, because we have 20 minutes left, let's go ahead and get these last slides knocked out. And if there's any further discussion or questions, we can definitely deal with it then. So now we're going to talk just a little bit about our virtual building that we're going to get to work with. So again, as you heard from Jing earlier this morning, this is powered by a product called BOPtest that was developed by the National Lab System. The main, next slide, Ted. I think I'm stepping on my own toes and getting ahead of myself. So what is one of the biggest challenges that you've run into trying to learn how to run a building on a live building? Okay, and I'm going to leave this as a rhetorical question. But isn't the answer that there are consequences to your actions? If you screw something up in a real building, the building that you're running, doesn't it make problems either for yourself or someone else? So it's not necessarily the best learning environment, right? So what do? We turn to simulations. Anybody in the group used a simulation training tool? I know they're in some of the trade schools, they're starting to push these a bit, where you prep for your lab by going through a simulation, where you kind of go through the same type of steps. Okay, they're getting more common. But the challenge with them is they're not the real world. You don't get a lot of the feedback that you would. It's a very artificial scenario, things like that. So it's kind of limited what you can get out of it. Okay. Next slide, Ted. So hey, I'm fully going to acknowledge with that great intro about simulations, we're using one. Okay. BOPtest was a project that was based out of the Lawrence Berkeley National Lab there in Berkeley, California, led by project leader David Bloom over there. Really nice guy, really sharp, really great team to work with, really interesting group. And they made a product called BOPtest. And what they did was they created some building simulations in a program called Modelica. You probably haven't heard of it, but it's a modeling tool that's used by small companies, you know, like GE, to design jet engines. Okay, so that's the level of modeling detail that this tool has. And what they've done is they've created a series of models of different types of buildings and control systems. So if we go back 2 slides real quick, Ted. There we go. Well, we can see this is a model of the building that we're going to be working with. We're specifically working with 1 floor on this building. We have 5 zones, north, east, south, and west, and we have a core zone. You can see the building dimensions, 50 meters wide by 33¼ meters deep. Our regular floor height of about 10 to 12 feet is applicable. Those will be the 5 zones that we get to play with, and we also have the air handler associated with those zones. We basically have 1 floor to work with. But it's not just 1 floor total. We each have a floor to work with. So we will, well, not everybody. We are splitting it down the middle. We have 24 folks, and we'll have 12 floors that we get to use. These are completely virtual, so if you manage to hose it up completely and make it 0 degrees in there, nobody's going to care. Nobody's going to come complaining. Nobody's going to complain about the utility bill or anything like that. All right. Back 2 more slides, Ted.
This one, or you want to go back one?
Back one. There we go. So BOP test is different because it creates this data for us to work with. It doesn't provide us an environment that we work with it in. So it does, however, have a driver that works with BACnet. So we could use any system that can tie into BACnet to monitor this virtual building that we get to play with. Okay. Next slide, Ted. We're going to be using a system by a company called Contemporary Controls. They're based out of Illinois. Both their corporate office and their manufacturing facility are there. And they make this product called BassView 3. Okay, it is a head end in a box. For those of you on the Niagara system, this is very much like a Jace. It self-hosts its web pages, it provides data logging, and it's all done through a web interface. Okay, that is what we will be using. We have a server up at the Flex Lab that Peter mentioned, and we saw in one of our earliest slides here, that is running 12 instances of BOP test. So it's running that simulation, creating that data, and sending it out to 12 of these BassView 3s. Each BassView 3 will have 2 of you logged into it, and you'll mostly be playing with either the north and east zone or the south and west zone. But you'll each have your own workspaces to work in, so it's completely isolated. At the end, we're going to start off, or I'm sorry, we're going to start with this simulation in a messed up state. Okay, nothing physically wrong with any of the sensors, any of the actuators, anything like that. We will have some problems inherent to the system. Problems that we will have the opportunity to go in and fix. Okay, overrides, schedules, alarms, things like that. We'll get to play with. And then on our last day, we're going to go back in. We're going to pull our energy data out, the amount of power that we have used throughout the process, the course of the time, and we'll go through and we'll analyze it. We'll see how much energy we saved on a building that's, or on each of the spaces, or the building in total, or floor in total, excuse me. Okay. That is what we will be working on for the rest of this project. Everything, you know, towards the middle or end of next week's session, that's what we're going to be doing, is we're going to be working in this virtual environment. Specifically next week, we're working on overrides. Okay. I got one more slide, and then we'll do another check for questions. So, homework. I can hear your groans from here. You're all muted, but I can still hear you groaning. Don't worry, it's not major. Okay. For next week, I would like you to do your best in your home system there, whether it's a Siemens system, a Johnson system, a Schneider system. If you want to go and find in the old Network 8000 system, you do it. We are looking for 2 overrides. Okay. Just find them. Find 2 points in your system that are overridden and do a little research to see if you can figure out why they were overridden. Okay. Was there a problem? Was there a schedule that got overridden because of a snow day or because of a late running event, parent-teacher conferences, something like that? Okay. Find those points. If you can resolve it, that'd be awesome. But generally, find 2 points. Find out as best you can why they're overridden. Basically, we're looking for a temporary fix or a long-term fix. and bring it back and be ready to talk about it next week. If you've got too many to count, that's fine. Bring 2 of your favorites. Okay. Does that make sense to everybody? Homework makes sense? Virtual building that we're going to get to play with makes sense? Got any remaining questions? And if you don't have access to a system to work with, don't sweat it. If you can't find any overrides in your system, you're a unicorn. Congratulations. Ted just put our contact information in the chat. So if you have any questions that you think of during the week, let us know. We'll probably answer them in email, but we may very well talk about them next week as well. That's the one disclaimer I'll give you. If you don't want it talked about next week, say so in the email.
Hey,
Last
Robert.
slide, Ted.
Hey, Robert, this is Larry. Before we sign off, I just wanted to ask if everything went okay in terms of technical technical issues related to Zoom.
Awesome question, Larry.
Okay.
So did anybody have any problems getting into Zoom? Any problems finding the tools here in Zoom? Anything like that?
Just the browser version is really stripped down and you can't do a lot in it. So I open up the client.
Yeah, if you're able, get your IT folks to let you install Zoom on your whatever computer you're using this for. It will make it a little easier.
Yeah, I had it. I just automatically open in the browser. We had an FBI warning not to use Zoom during COVID that we disregarded. We had to sign a disclaimer. I was against it entirely. I mean, we're a Microsoft shop, so I was like, let's stick with what we got. But...
And one other thing, a copy of this video will be posted when? I'm not sure if Kim is on the call right now, and how will they access that?
So the video will be posted as soon as we can get it up there. You probably came in through a lobby, so where it had the series of events logged in. So when you go back there, when the video is posted under today's date, it will say view or view video instead of where you clicked earlier to join. Great question. Thank you, Peter. Looks like all our feedback is looking great, Larry. So no problems, no issues.
Good to hear.
Hey, Justin, can I have some of those donuts?
That's right, Justin. Your homework for next week is to bring donuts.
I know I'm gonna get myself in trouble here.
Yeah, I'm not a fan of virtual donuts, by the way.
Oh, you prefer cookies, Ted?
No, I don't like virtual donuts. I'd rather have real donuts.
I got your joke.
Thank you.
Yeah.
Well, Ted, next week, bring your own.
I'll have to. I'll have to.
All right. Any further questions, comments, or concerns?
I agree.
I can't wait
Happy
till we get
hour.
on Bob test. That's good. Should be fun.
All right. Well, thank you, everybody. It was a wonderful first session. I look forward to seeing you all and working with you further next week.
Thank you, everybody.
Thank you. Bye, everyone.